Hey, this is Juan Tutors, and we are working today on the June 2024 Geometry Regents, the Common Core Geometry Regents for June 2024. It's actually the third to last Regents of this of these standards. They are changing at the end of next year, and so this is really exciting. This is literally one of the last ones that they're ever going to give with these standards. My goal for this video is to just basically create the GOAT of all videos for the June 2024 geometry regents, which means that I'm not just going to do the problems, I'm also going to show you what I do for a process of elimination in tools that are accessible to almost every student to turn problems into problems that are point increases. Because I know a lot of you are literally just trying to pass the geometry regents. Some of you have passed or have barely passed and are going to take it again to pass. Some of you know you're going to pass, but you're trying to get an 80. Some of you have been getting 80s, but you're trying to get a 90. And some of you really are trying to ace the test. So I really want to get you to the point where you understand not just how to do the problems, but also how to eliminate answers that are just not correct. So I really want to create the GOAT of videos. So if you feel that it is the GOAT of videos at the end, just type "this is the GOAT of videos" and let me know. So there are a couple of things I want to just discuss. I promise I'm not going to hammer into the nitty gritty details that you might not care about. This is the front of the page. You can read it, and it is worthwhile to read it so that you know what's on it. There's just a couple of details from that front that I want to address because they're actually relevant to you getting the best score possible. So, for example, number one, clearly indicate the necessary steps, including appropriate formula substitutions, diagrams, graphs, etc. That is what they say to do for the part twos, threes, and fours. As you know, for the part ones, we don't look at your part ones to grade your test. We only look at your answer. However, if you actually look at the part ones versus the part twos, threes, and fours, there's plenty of part one questions that if you just cover the multiple choices, that's a part two, or cover the multiple choices, that's a half of a part three or a third of a part four. So it literally means that if you are trying to eke out as many points as possible from the test, you actually have to show all work for the part ones. And I'm telling you this, and just my goal is to get you the highest score possible, and I know you could do it. I believe in you, but it does take showing work. So if you happen to be in a school where the teacher has been battling you for the whole year saying you should definitely show work and you've been fighting it, and let the teacher win. The teacher is actually right. You should be showing work on every single problem. And I'm telling you this as a person who's graded multiple regents. This I'm gonna just keep scrolling real quick. This is what regents tests normally look like when students submit them blank. In other words, they don't show work. This is actually what, if you look at my test, and I'm gonna share my PDF with you, but this is just I'm just literally, you don't have to read what I'm writing. You just have to see that there is a ton of writing, and that's actually what your test should basically look like for the part ones. If you want to maximize your score, that's what you should be doing. Okay, so that's number one. Number two, utilize all information provided for each question to determine your answer. There's something we almost did you a disservice in elementary school when we taught you to cross out irrelevant information. That's actually a lesson that is taught in elementary school classes, and then kids leave thinking that there's always going to be irrelevant information in math problems. And in fact, what's irrelevant is things like, is Susie going to the store to buy cantaloupes, or is she buying watermelons, or is she buying water bottles, or something, or is she buying iPhones? Like all of those things, the thing that she is buying isn't relevant, but all other details, all relevant, all mathematical details are extremely relevant. In fact, I've seen one test in my life that I can recall that had one piece of numerically irrelevant information ever. Ever. In other words, every single other test that I've seen, every piece of numerical information was relevant. Even and I'll say an exception. There were two other problems where there was one piece of information that it wasn't that it was irrelevant. It's that if you actually solved it a certain way, you needed that information. But there's another way to solve it that didn't require some information. So total really of 3 problems ever in my life for all Regents, for all SATs that I've ever seen, all ACTs that I've ever seen, all AP calculuses that I've ever seen, the one AP pre-calc, because it's a new test that I've seen. Every piece of mathematical information was relevant. So if you're ever stuck on a problem and you can't figure it out, go back and read it. Read it carefully. Don't just look up and see. Go read it carefully and make sure there's not a numerical or mathematical detail that you haven't yet used, because it's usually the thing that when I'm tutoring students on tutors.com, it's when I'm tutoring students, it's usually the thing that they miss. Okay. So next, note that diagrams are not necessarily drawn to scale. This is a place where a lot of teachers disagree with me, but I actually like to do that. Cross it out. Cross it out. Why am I crossing it out? Now, I don't recall right now if there were any diagrams in this test not drawn to scale, but here's the reason I cross that out. Back in the day when I took the SATs, and actually just even a couple of years ago, the SAT used to punish you in quotation marks, made you lose a quarter point in your raw score if you got the question wrong, but had you gain a point if you got the question right. And a lot of students were like, "Oh, it's meant to punish you for getting it wrong," and that's actually never been the point. The whole point had always been that a completely wild guess where you didn't even read the question, you just filled out a number anyway, that is actually worth 0 in that situation. But what happened? Students would get to that test and they would read it and say, "Oh, that must mean that if I don't know the answer, I should leave it blank." Not true at all. In fact, if you don't know the answer, but you did literally anything with the problem, it's almost always the case that you should answer the question 100% of the time. 100% of the time. So why am I making an analogy to this note that diagrams are not drawn to scale? Students read, note that diagrams are not necessarily drawn to scale, and they think, well, that means that diagrams aren't drawn to scale. When in fact, it's the case that almost 100% of diagrams are drawn to scale. In fact, almost 100% of tests, geometry tests, have all diagrams not drawn to scale. Occasionally, there's a diagram not drawn to scale. I've seen three tests. I think I said 3 tests last time that had 2 diagrams not drawn to scale. And the entire test and everything else was drawn to scale. And I've never seen a test with 3 diagrams not drawn to scale. There is one problem in this test where, like, you and I could maybe fight a little kumite if you want to say it's not drawn to scale and I say it is drawn to scale, and we might actually disagree, and I might change my mind later in life. I don't know. And we'll talk about that problem, why I'm talking about scale, and maybe it's drawn to scale and maybe not drawn to scale. Might sound funny. It has to do with 3 dimensions. But we'll talk about it when we get to it. Again, I'm trying to make the GOAT of all geometry regions videos with this video. So I'm trying to give you all the information. I promise I'm going to get to the problems right away. But if you want to just skip to the problems, go ahead and do that. But this is how I tutor my students. And my students, I take students from 60s to 90s in 1 or 2 sessions. And parents are like, that can't be possible. Then they hire me, and it's literally 60s to 90s in one, sometimes 1 session, sometimes 2 sessions, sometimes 3 sessions. Happens to me all the time. I'm talking about a 500 on an SAT turns into a 750 on an SAT. 21, 22 on an ACT turns into a 32, 33 on the ACT. So please take my word for it. Or do your own thing, but I suggest taking my word for it. So this was the third thing. And then the fourth thing is that the formulas that you may need to answer some questions in the examination are found at the end of the examination. Now, that said, I'm not deleting any edits. I am literally going and working until I am done with this Regents. Now, about the formula sheet, that's an extremely relevant piece of information. So let's actually scroll down to the bottom. That's too far. Nope, that's not too far. That's not far enough. So I'm not going to go through every single formula here, but I just want to go through what's on it. Some unit conversions are going to be relevant. So if you don't know how to convert between certain units, those are going to be right on the formula sheet. So, and then there's a lot of formulas that are extremely relevant for the test. So if you don't remember the formula for the area of a triangle, that is one that almost every student remembers, the formula for the area of a triangle. It is 1/2 base times height. Uh, but then students get stuck with the formula for the area of a parallelogram. Area is base times height, not the they mess up sides. Circle area versus circumference, prisms, cylinders, spheres, cones, pyramids, Pythagorean theorem, quadratic formula, arithmetic sequence, geometric series, radians, degrees, conversions, which is relevant, especially in algebra 2, but not so much in this one, and exponential growth and decay, also not so relevant in this one, but there's plenty of formulas. In fact, the whole left side and the top and a bunch of the right side, 3/4 of this formula sheet literally is on this test. So definitely do uh, look at the formula sheet and make sure you're comfortable with it. Now that's that, and I will look at the formula sheet whenever it's needed. So right now we're gonna get to part one. Part one says a bunch of stuff, and I do want you to read that. But the big thing is, note that diagrams are not necessarily drawn to scale. You know how I feel about this. I cross it out, and I actually train my students to cross it out and the reason is that if you don't know how to do the problem, if you assume that it's not drawn to scale, you're going to get it wrong, almost because you're going to be wild guessing. But in fact, if you go, this is now test taking strategy. That's the reason. That's the big reason. It's not about facts versus fiction. It's almost guaranteed to be drawn to scale. Test taking strategy says if it's almost guaranteed that the diagram's drawn to scale, might as well use the scale. And so that's the hint. If you don't know how to do the problem, assume that the diagram's drawn to scale, see if it just gives you an answer. And in this test, we are, as a test taker, as an attempt to make the GOAT of all videos, I'm going to actually show you how to confirm whether the diagram is or is not drawn to scale. So let's do that. Now, in the diagram below, this is triangle, the problem number one, numero uno. In the diagram below, BRI is the image of triangle JOE after a translation. Triangle CAT is the image of triangle BRI after a line reflection. Which statement is always true? R congruent to T, J congruent to A, JE congruent to RI, or OE congruent to AT. So one thing I will say right now, in a previous video, I gave everyone a minute during the video to practice. I actually highly recommend pausing the video. I know a lot of video makers say pause the video and try it on your own, and then almost no students do. But I happen to see in my video data that some of you do, and the ones that you do are almost guaranteed to get better grades. This is the thing that I want you to do. I want you to pause the video, choose an answer, pause the video, choose an answer, and then when you do choose an answer, but stick to it. Stick to it. Don't say I think it's this one, because if you think it's this one, but I'm going to choose this one, that's a bad strategy. Or I think it's that one, so I'm going to choose that one. Or I think it's this one, but you don't actually commit to it. Then the moment I give you an answer, you might convince yourself, oh, I knew it was going to be that one. You have to stick to it and see why you were wrong. That's my advice. Or see why you were right. So, in terms of assuming things are drawn to scale, well, I and E and T look about the same size. And now the other angles, this looks kind of like an isosceles triangle, so it's hard to say about the other angles. But does it say that like I or and E are congruent, or I and T are congruent, or E and T are congruent? It doesn't say that, so we didn't get lucky. But what we can do is look at the order of the vertices as written. This is actually a rule. The vertices of the triangles actually have to be given in corresponding vertex order. If they're in corresponding vertex order, that means that vertex B has to correspond to vertex J, and that has to correspond to vertex C. Vertex 2 R, so the second vertex has to correspond to the second vertex. You get the point. This third vertex has to correspond to this third vertex and this third vertex. Okay, and now let's see. So which statement is always true? Angle R is congruent to, well, actually, let's mark these things. 1JB, I'm going to mark it with an arc with 1 dash. J, an arc with 1 dash. C, an arc with 1 dash. R, an arc with 2 dashes. O, an arc with 2 dashes. and T, an arc with 2 dashes, and then I, an arc with 3 dashes, E, an arc with 3 dashes, and T, did I mess that up? There we go. There's an error, and I'm going to fix it. A, sorry, gets an arc with 2 dashes because that's the second letter. So if you're wondering why I said T gets an arc with 2 dashes, you are actually right. A is the second letter, so it gets an arc with 2 dashes, and T it's the third letter. It gets an arc with 3 dashes. Okay, so now which angles correspond to each other? It says R congruent to T. That's arc with 2. That's an angle with 2 dashes, and an angle with 3 dashes. That's not it. Also, this okay. In terms of scale, if I assume drawn to scale, one angle is slightly bigger than the other. Okay. The second one, J congruent to A, that's an arc with 1 dash congruent to an arc angle with 2 dashes. That is wrong. I think I said arc, angle. Angle with 1 dash congruent to an angle with 2 dashes. No, they don't correspond to each other. Now JE corresponds congruent to RI. JE, that's this side, 1 dash matching with 3 dashes, congruent to RI. RI, that's an that's R with 2 dashes and I with 3 dashes. So I'm going to put 2 dashes there. Okay. That those don't correspond. 1 and 3, 1 and 3, and this is 2 and 3. 1, 3. This is 2, 3. Okay. Now, so that one's not it. And then finally OE, which is 2 and 3, congruent to AT, and this is 2 and 3. So those do correspond to each other. So that is the answer. Hopefully I was able to make you understand this. Again, this is literally asking, number one was literally asking you, can you read the vertices? And do you know that the vertices have to, by rule, be given to you in order? That's literally it. Number two. A right circular cylinder is cut parallel to its base. The shape of this cross section is a cone, circle, triangle, or rectangle. Now, some of these answers don't make sense, but it's a right circular cylinder. Though, how do I do this problem? You should be drawing a right circular cylinder for this problem. So you draw a right circular cylinder. Okay. And then you have to think about what kind of cross sections you might get. So what is a cross section? There's a cross S crossed out. What is a cross section? Imagine that this cylinder is made of like salami, or this cylinder is made of butter. Something soft, something that you could cut through with a nice knife. Now, when you slice through it with a knife, what shape is the surface that you're looking at when you cut it? That's all that a cross section is. That's literally all that a cross section is. So you can cut with a knife horizontally. And if you cut horizontally, you're going to be left with a circle. Okay? If you cut diagonally, maybe I should do this in a different color. If you cut diagonally, you're going to be left with something that looks like a circle, but it's not because it's elongated. That is an ellipse. If you cut vertically, now you actually cut that way, straight line, going straight line, going straight line, straight line, you get a rectangle. So that's basically what you can get, a circle, an ellipse, and a rectangle. And some of you are saying, wait, but isn't there something else that I can get? Like if I cut kind of through the surface on top, but at a diagonal. And yes, that is actually one of the things that you can get. You can get an ellipse with the ends cut off. Imagine like you literally cut a salami diagonally, and then you cut off the ends of the salami. So you get an ellipse with the ends cut off. Or one end or both ends might be one or the other. So the answer to this question, well, I said that some of these don't make sense in terms of the surface that you get. First off, a cross section is two-dimensional. and flat. Remember, we said cut with a knife, a nice sharp knife. What surface do you look at on the surface that you cut out? So, uh, you can't get a cone because that's not flat. You can't in principle get a circle. We just talked about it. You can't get a triangle because you can't get three sides. You can't get three straight line segments from a rounded figure, not in at all. So it's either going to be a rectangle or a circle. Now, what is a passing problem? For me, what I call a passing problem is equal to a problem with two answers with 100% eliminated. Now, when I say 100% eliminated, I mean that you know with 100% certainty that those answers are wrong. And we'll talk about 100% certainty later on, but you know with 100% certainty that it's wrong. So these choices are wrong. 1 and 3 are definitely wrong. Why is this called a passing problem to me? Because the number of points that you need to pass this Regents, it tends to hover between 25 points and 29 points out of like 82 or 80. Um, so or 86, one of those numbers. I gotta look at it again. I'm confusing the new algebra with the old algebra and then geometry. The scores change, so we'll look perhaps later. But what that means, 25 to 29 problems, literally there's 24 multiple choice questions. So if you get to a question and you've eliminated 2 out of 4 choices, now the probability of getting it right is 50%. 50% of the 2 points that this question is worth is 1 point. On average, if you that is a that moves you towards a passing grade, and then you really have to figure out how to pass with the rest of the problems. That's why the process of elimination stuff that I'm teaching you using correct math is a great way to go. Okay? So, now we have a passing problem. Okay? So now this said parallel to its base. That's the key that we need. We need parallel to its base. The base is on bottom. So we have to go parallel to its base. So we are cutting horizontally. We're going to get this a circle like this. If we cut perpendicular to the base, we would get a rectangle. But since we went parallel to the base, we got a circle. Sweet. Notice all the work that I just did. I drew that. I had to show work to get full credit, didn't I? No, they're not looking at my work. Yes, I still had to show full work to get full credit. You know? So, all right. So, number 3. What is the minimum number of degrees that a regular hexagon must rotate about its center to carry it onto itself? Is it 45, 72, 60, or 120 degrees? So, definitely, again, I would say do the problem on your own. Think about what you need to do to be honest with yourself and do the problem. I would say that you would need to draw a diagram. So I would highly suggest pausing the video, drawing a diagram, trying to determine an answer. Stick to an answer before you see me do the problem. I know that some of you do that because I see the analytics of the video. So this over here, we have an isosceles, a regular hexagon. You do need to know that a hexagon is a 6-sided figure. Some students get this wrong right off the bat by not knowing that a hexagon is a 6-sided figure. They think it's an 8-sided figure. Now notice that my hexagon is a little bit wiggly. It's not perfectly straight. If you wanted to pull out the straight edge, then pull out the straight edge. And it is worth your time to draw as best as you can an isosceles and a regular hexagon. It is worth your time. So how do I do this problem and find the minimum number of degrees? So I have 6 sides. So if the rotation is gonna carry the regular hexagon onto itself, then I know that I could rotate 6 times to get the full turn back to the original positions. So if I did A, B, C, D, E, and F, 6 turns will make it go back to not only its original self, but also every vertex will be back to where it was. So if I do 72 degrees, 72 times 5 is 360, not 72 times 6. Times 6 does not equal 360. So that's eliminated. Times 6, not equal to 360. Now times 6. Now this one, now notice I crossed this one out because I know it's 100% wrong. Now this one I multiply and I get 720. And this one I multiply by 6 and I get 360. And if I struggle as a student, I might struggle to know which one I should eliminate. However, I've turned this into a passing problem. I turned this into a passing problem because I know that I've choice 1 and 2 are 100% incorrect. Now, why might I struggle, even as a non-struggling student with this answer? I multiply by 6 and I get 360, and I multiply by 6, I get 720. Well, 720 also carries every vertex back onto itself. So I might struggle, but I have a suspicion that this one might be wrong. So I might make a wise choice and choose choice 3. All right, which would actually be correct. Now, notice these two, I put an X on the number because I know with 100% certainty those are incorrect. I put an X next to 4, not on 4 like this, because my simulated fake student me is unsure whether 4 is incorrect. Now, what do I mean by fake student me, by the way? When I say fake student me, I mean me simulating myself as a student as opposed to me being the tutor who's been doing this for 25 years. Actually, 25 years as of 10 days ago, quarter century that I've been tutoring. So that's awesome. For me, I'm actually super excited about that. Now, what about choice 4? Is it that makes it incorrect? I realize that 120 times 3 is equal to 360. So this will rotate the 3 times. If I rotate this 3 times 120 degrees, I get right back to every vertex back to where it belongs. But that's not the minimum, because I could actually rotate A to B, B to C, C to D, D to E, E to F, and F to A. So I should be able to rotate 6 times, not just 3 times. Therefore, choice 4 is wrong. Now, is there another way that I could argue this? Another argument is this: 360 divided by the number of sides of the regular hexagon. Notice that this is a regular hexagon of the regular n-gon. So if it's a regular n-gon, it could be a regular 8-sided octagon. It could be a regular decagon, 10 sides. It could be a regular dodecagon, 12 sides. But this one is 6-sided. It's 360 over 6 is the minimum number of degrees, which is 60 degrees. Okay? Why did I go through all that explanation? Because again, I need you to have, one, some intuition on how to do the problem, and also I need you to be able to eliminate some answers. Every single multiple choice question, I am going to give you a way to eliminate at least some of the answers. Sometimes I'm even going to give you enough information to eliminate all of the answers. So we'll see how that goes. All right, numero 4, number 4. In the diagram below, let me scroll down a little bit. A sphere is inscribed inside of a cube. The cube has edges of length 18. What is the volume of the sphere in terms of pi? So, if you don't know how to do this problem, again, do something. Notice that the previous 3 problems, I used correct math to eliminate some choices. There's a difference between guessing versus using correct math to 100% certainly eliminate some choices. And these answers have a huge range from the smallest 108 pi to 432 pi, which is 3 times as big, or more, 4 times as big, to 972, which is 8 times as big, to 7776 pi, which is over 70 times as big? Yeah. So yeah, just had to think about it for a second. That is a huge range. A 70 times factor, a multiple of 70 factor between all the answer choices means that you should be able to eliminate some choices just by some process of elimination using correct math. Okay, so now first off, let me get a detached LCD so you could see it a little bit bigger. Okay, so one method for process of elimination that I might use is the following. Okay, I am going to take the cube and find out its volume. Well, it's 18 times 18 times 18. That's 18 cubed is 5832. So the volume of the sphere is less than 5832 because it's contained inside of the cube. So if I do 7776 pi, well, 7776 is already bigger than 5832, right? Last time I checked. Multiply that by pi, it's even bigger than that. So that's automatically wrong. It's too large. But now, what about, are there any answers that I could eliminate based on this answer? Look at this math intuition. Look at this geometry intuition. The sphere is touching the sides of the cube. So the sphere is not an extreme amount smaller than the cube. Now there is a little bit of a visual intuition that starts to fail when we go to 3 dimensions, because in 2 dimensions we see size very easily. In 3 dimensions we have trouble seeing the size. So I will say this, that the difference in the volume of a cube and the volume of a sphere is a little bit bigger, slightly, only slightly bigger than you might suspect. But I'm going to say that they're close-ish. Okay? In other words, the volume of the sphere is not extremely less than, that is an actual technical symbol. 2 less than symbols, extremely less than. So the volume of the sphere is not extremely less than 5832. So if I actually go into my calculator and put some of these numbers in, and I put 108 pi, that's 339. It's like almost more than 10 times smaller. Too small. With 100% certainty. Too small. Now I have a passing problem. A passing problem being a problem that I have a 50-50 chance of getting it right, just from geometric intuition. Notice I used correct math to eliminate choices. I have a passing problem. Now, 432 pi, a passing problem meaning again, a problem that leads me towards a passing grade. 4032 pi. Now, maybe I may lack a little bit of intuition to be able to eliminate or not eliminate this one, because 1357 compared to, I did say that they're close-ish. 1357 versus 5832. Maybe as a student I struggle to eliminate this one, but then I go to 972 pi and I get 3053. Okay? So this is around 3053. And what was the other one? 1357. Okay? Now, fake student me might look at this and say, actually, though, I know that they have to be kind of close. 3053 is somewhat close. I feel like 1357 maybe is a little bit too far. So fake student me might actually eliminate choice 2 even next to the 1357 and then stick with number 3 despite fake student me not knowing how to do the problem. Because 3053 is just close-ish enough to 5832 to make sense. So even a student who doesn't know how to do the problem might actually get this right. And in fact, if you actually have enough intuition, visual intuition, you might actually be able to visually tell that 1357 is entirely too small. But maybe not. So what about how to do the problem? So I'm liking this one as a fake student me, but I'm not liking number 2. But how to do the problem? what a lot of students don't catch, but a lot of advanced students catch, is that if you draw a dot at the center of the sphere and then draw a line to the edge of the sphere, that is R. But if you draw a line to the other side of the sphere, that is also R. And notice that that spans exactly from the center of one side to the center of the other side, perpendicular to the opposite side, which means that R plus R is equal to 18, or 2R is equal to 18, divide by 2, or just recognize that that means that R is equal to 9. And now we have the radius of the sphere, and we can go to the thing I told you you should be comfortable looking at, which is the formula sheet. The formula sheet does have the volume of a sphere right here. That rhymes. Now we have the volume of a sphere, v equals 4/3 pi r cubed, and we have r, with the 1 degree of freedom that the sphere has. So v equals 4/3 pi times 9 cubed. Now I notice that the pi is left in the answer, so I keep the pi out of my calculator and just bring it with me. So multiply by pi, keep the pi there. But now multiply 4/3 times 9 cubed. 4/3 times 9 cubed, 972. 972 pi. There's my answer. There it is. See that? Not too bad. Not too tough. Número 5, number 5. So in the diagram below, EM intersects HA at J. Let's see if that's true. Yes. And EA and HA are perpendicular. I'm going to draw that mark right now. And also EM and HM are perpendicular. So those are perpendicular. Now, I'm looking, let's talk about drawn to scale. DTS. If you see me say drawn to scale, DTS, that's drawn to scale. So the piece of advice that I gave about crossing out, note that diagrams are not necessarily drawn to scale. If you don't know how to do this problem, go ahead and assume that it's drawn to scale. You might find that you get an answer. Maybe we'll even test that before we do the second piece of advice. EA is 7.2. EJ is 9. AJ is 5.4. And HM is 3.29. What is the length of MJ to the nearest 100? Now, I'm going to say, again, suppose I'm a struggling student. I have no clue how to do this problem, but I assume everything's drawn to scale. And then I say, well, JM is shorter than HM. So since HM is 3.29, JM's got to be less than 3.29. Now I'm left with choice 1 or choice 2. Now, choice 1 and choice 2 are so close to each other that I don't know which one to pick, but I have a 50-50 chance of getting it right under the assumption that the diagram's drawn to scale. And since there's an extremely large chance that the diagram's drawn to scale, remember, if there's 20 diagrams, and let's say one is drawn to scale, there's a 95% chance that the diagram's drawn to scale, assuming that there's a 5% chance that one of them is not drawn to scale. Look at this. I got a 50-50 chance of getting it right, which means 2 out of 4 chance of getting it right. Multiply that by 0.95. If you assume it's a 95% chance of it being drawn to scale, it's more than 95%. It's like 97, 98%. But let's say 95% chance that it's drawn to scale. I have a 47.5% chance of getting it right now, up from 25%. I have a 1 in 2 chance of getting it right. It's literally a passable problem. In very technical sense of the word, what I call the passable problem, if you have a 50-50 chance of getting it right, it's a passing problem. It's a passing problem. This is 47.5, so close to 50%. It's a passing problem without me even knowing if it's drawn to scale. So take my advice. But what's better than assuming it's drawn to scale? Confirming that it is drawn to scale. So now EA is 7.2. And EJ, first off, they're perpendicular. All the lines that look straight are straight. That's actually a requirement in geometry class. EA perpendicular to HA. If I turn my head, those look like very much right angles. And then they said EM is perpendicular to HM. That definitely looks like a right angle. That's drawn to scale so far. EA 7.2, nothing can contradict the 7.2 until you get to another number. EJ is 9. EJ is 9. So EJ being 9, it's a little bit bigger than 7.2. Half of 9 is 4.5. 7.2 is a lot more than half of is a lot more than 7.5. So 7.2 should be closer to the 9, and it is. AJ is 5.4. That looks reasonable. 5.4 looks more than half of the 9 and less than the 7.2. Definitely drawn to scale so far. HM is 3.29. 3.29 is around half of, it's a little less than half of 7.2. And HM looks like a little less than half of EA. Drawn to scale so far. And there's literally nothing else left to contradict. There's no more numbers. We just confirmed that it's drawn to scale. So if you assume it's drawn to scale, you're 95% of the way. If you confirm that it's drawn to scale, you are 100% of the way. Now we've confirmed that the answer has to be between less than 3.29, and 3 and 4 are definitely incorrect. We used to have this where we thought 3 and 4 were incorrect, but we weren't sure because we assumed that it's drawn to scale. But now we confirmed that it's drawn to scale. 3 and 4 are definitely incorrect. 50-50 chance of getting it right. So now the question is, how do we do the problem? Unfortunately, these numbers are so close to each other that I wouldn't even be able to tell you how to eliminate one versus the other than doing the problem. Now, what do we need to do? So, well, we have to confirm that these triangles are similar, and these triangles are similar. So angle A is congruent to angle M. And the reason is, notice that I'm going to give a statement and a reason, because in this part 2 question, you'd have to give the givens, right? Givens. But since this is not a part 2, 3, or 4, I'm not going to give the givens. So this point here, A is congruent to M because perpendicular lines form congruent right angles. Nice. Okay. And then these vertical angles are congruent. Angle EJA is congruent to angle HJM because vertical angles are congruent. Therefore, the triangles are similar. Now I have to give the triangle names in the correct corresponding vertex order. I'm going to go start with the right angle, A and M. Then J and J correspond to each other, J and J, and then E and H. So triangle AJE is similar. I said congruent. That's a typo. If you caught that typo, let me know. Similar. So triangle AJE is similar to triangle MJH by the angle-angle postulate. And now by the angle-angle postulate, corresponding sides are in proportion. Now I gave these vertices in this order because you're actually required to give it in that order. Although I will say this, when you do a proof, they're a little bit loose on your writing, not on their writing. They do have it in the right order. There have been typos in the past where they gave it in the wrong order, but there weren't any of those typos here. If you write it in the wrong order, they might forgive it. Usually they just don't notice, to be honest. So if I put it in this order, 1, 2, 3, 1, 2, 3. So I'm going to label these 1, 2, 3, and also 1, 2 is already labeled 3. So now I can actually create a proportion of corresponding sides. So I have 3 and 1, EA, over 1 and 2, AJ, is equal to the same proportion of the sides on triangle MJH, 3 and 1. So this is 3, 1, and 1, 2. That's a 2. So I have to do 3, 1, and 1, 2. 3, 1 is HM and MJ. And now I have 3 of those numbers, and I'm missing the fourth one, the one that I'm trying to get. So EA, let's see, 7.2 over 5.4 is equal to 3.29 over MJ. MJ is what they want, right? So that's okay that I don't have MJ because I could cross multiply. I used to be an enemy of cross multiplication because I liked other methods, but now not so much. 7.2 MJ is equal to 5.4 times 3.29, and then divide by 7.2. Divide by 7.2, and we get our calculator out. Okay. Move that over here so you can see it a little bit bigger. So 5.4 times 3.29 divided by 7.2. And we get 2.4675. 2.4675. So MJ is approximately equal to 2.4. The 7 after the 6 makes the 6 round up to 7. Up 1 to 7. Okay? 2.47. So it's that answer. I don't know if I covered the drawn to scale with my picture. DTS means drawn to scale. Okay. Notice we confirmed that it was drawn to scale as opposed to just assuming that it was drawn to scale, right? So, okay. Sorry, I just messed that up. Okay, why do I? Okay. Remember, every single thing that I would normally edit out, I'm not editing out this time. So, okay, numero 6, number 6. Which equation represents the line that passes through the point 2, -7 and is perpendicular to the line whose equation is y equals 3/4 x plus 4. Passes through the point 2, -7 and perpendicular to this line. So how do we eliminate answers? So we have y plus 7 equals 3/4 x minus 2, y minus 7 equals 3/4 x plus 2, y plus 7 equals -4/3 x minus 2, and y minus 7 equals -4/3 x plus 2. This is what you call a 2x2 problem. So how is it a 2x2 problem? If you can eliminate, there's 4 choices, but if you could eliminate the correct two sets of details, you get it right. But if you could confirm that any one set of details is incorrect, you eliminate some choices. In fact, you could have confirmed 2 sets of details independently. The order of the operations is plus or minus, plus and then minus, or it's minus and then plus when we read left to right. And then the question is also, is the slope 3/4 or is the slope -4/3? And so which ones of these are, so plus minus is choice, and slope 3/4 is choice problem 1, choice 1. Choice 2 has a minus and a plus and has a 3/4. And then choice 3 has a plus and a minus and has a slope of -4/3. And choice 4 has a minus and a plus and it has a slope of -4/3. So how do we eliminate some choices? And you don't have to make this box. I'm teaching you what a 2x2 problem is, what I call a 2x2 problem, so that you can recognize it when it comes up. The only things that are changing are the plus minus versus minus plus, and also 3/4 versus 4/3. And those 3/4 versus 4/3, also plus minus versus minus plus. 2x2. Okay, so some of you may recognize that this says perpendicular, right? And even if you don't remember how to find a perpendicular line, you may remember that parallel lines have the same slope. So then you remember perpendicular lines have, and then you might be struggling. What do they have? What do perpendicular lines have? Well, I don't know, but fake student me says if parallel lines have the same slope, perpendicular lines probably don't have the same slope. Okay, so I am going to go ahead and eliminate something. Any that have the same slope, I'm going to eliminate. Slope equals 3/4. So the slope of a parallel line equals 3/4. Slope of a perpendicular line equals some mystery number, but it's probably not 3/4. I'm going to guess that this is incorrect, and I'm going to guess that this is incorrect. And then I remember, wait, I'm going to guess that it's incorrect. No, a line can't be both parallel and perpendicular to another line. No, this is 100% incorrect. Now I have a passing problem. I have a passing problem, which is super duper. Passing problem leads me straight towards a passing grade. I only have to struggle with the rest of the 23 multiple choice problems and the part 2s, 3s, and 4s. And by the way, I said that the part 1s are exactly like part 2s, 3s, and 4s, just without the multiple choice. They can easily, literally say, algebraically determine the, even in geometry, algebraically determine the equation of a line that passes through a point 2, -7, and is perpendicular to the line whose equation is y equals 3/4 x plus 4. That could be a part 2 problem. And they might say the graph, the included graph paper is optional or something like that. So there we go. So what do we need to remember? Perpendicular lines have opposite reciprocal slopes. Opposite. So the slope is, the original slope was positive. So the slope perpendicular is a negative number. The original slope was positive, so the new slope is a negative number. And then reciprocal, the reciprocal of 3/4 is 4/3. So the slope is, with 100% certainty, negative 4/3. Okay. Now, the point slope form of a line. Some of you might have done the 2x2 and eliminated not choice 1 and choice 2, but maybe eliminated 2 of the other ones because you happen to remember the point slope form of a line. Y minus y1 is equal to m parentheses x minus x1. Notice that we're subtracting the x coordinate and the y coordinate of the line that it goes through, of the point that it goes through. And then x1, y1 is equal to a point on the line. And we're subtracting x1, y1. So we're subtracting 2 and we're subtracting 7, -7. So y minus y is -7, parentheses, is equal to the slope, -4/3, parentheses, x minus 2. So y plus 7 is equal to -4/3, parentheses, x minus 2, which matches exactly choice 3. You may have actually, when you had done it, you may have eliminated choice 2 and choice 4 because you remembered you have to subtract 2 and subtract negatives, and subtract, not add 2, and also you have to subtract -7, not subtract 7. So if you remembered both of those details, you would have gotten the question right, which would be great. Okay. Let's scroll down a little bit more. Okay, numero siete, number 7. In triangle RHM below, the measure of R is 110. Let's look for drawn to scale. 110, this is an obtuse angle, slightly bigger than 90. Okay, that looks good to me. And the measure of angle M is 40. That looks like slightly less than a 45-degree angle. So that's looking good to me. And I might, just to confirm that it's drawn to scale, 110 minus 40. I'm sorry, 110 plus 40 equals 150. And 180 minus 150 is equal to 30. And that's 30. So I'm already doing math before I even do the problem. So this triangle is drawn to scale so far. Now, they say if triangle RHM is reflected over side HM to form quadrilateral RHR prime M, which statement is always true? Is quadrilateral RHRM R prime M a parallelogram? Or is the measure of angle MHR prime 40 degrees? Or is the measure of angle HMR prime 40 degrees? Or is MR congruent to HR prime? Now, I suppose that I, as a student, I'm not sure how to do the problem. I notice, though, number 2 and number 3 contradict each other. They can, in theory, both be false. But I have a gut feeling, based on how many problems I've seen, that it's probably going to be choice 2 or choice 3. I don't know, but the reason is that they contradict each other. Now, is there anything that I could do to eliminate some answers? Well, I might say, if I do that reflection, remember it's a reflection over MH. One thing that I would definitely do is actually draw it out. Okay, so if I reflect R over MH, that reflects perpendicular. So maybe there or so. And now I draw, so that'll be R prime. And I draw HR prime. Notice I'm using my straight edge. Is that so curved that it doesn't want to draw it straight for me? Let's try it again. I'm using my straight edge. Now, my straight edge is software, but you have a ruler during the test. Oh, come on. There we go. You have a ruler. So you can, and I actually do suggest that you take your time to actually draw that with your ruler so that you could actually get some visual intuition. Draw R prime so that this R prime is perpendicular to MH because it is a reflection. That is true. And then I notice things about this diagram. It violates a few things that parallelograms seem to satisfy. Like opposite sides are congruent. Actually, this and this correspond to each other, and this correspond to each other. So actually, now I know that it's not a parallelogram with 100% certainty. And then I have MR congruent to HR prime. Why would MR be congruent to HR prime? I don't have a good reason for that. And in fact, I could actually prove that that can't be the case. Because if I actually just keep M still and I keep R still, that forces R prime to stay still so that MR can't change. Now, if I take H and just pull it that way really far, I just literally pull it that way really far, that changes the length of HR prime. You can't have a length that's changing congruent to a length that is forced to not change. So this one is definitely wrong. Okay. So it's either that it's MHR prime is 40 or HMR prime is 40. So at this point, I would suggest putting some thought into it and seeing if you could do it on your own. Again, I would have done that before I even did the problem. But MHR prime is 40. Let's see, MHR prime, that's this angle. And then we have HMR prime. One of these is 40. Actually, though, we could actually determine which one of these is 40 by recognizing that we reflected over MH, which means that this angle, the 40-degree angle, is reflected over MH. So this is a 40-degree angle. And also, not only that, RHM, this angle RHM is reflected over the line MH. So this angle has to be 30 degrees. So HR prime is actually 30 degrees. And HMR prime is 40. Not bad. Not bad. Number 8. The funnel shown below can be used to decorate cookies with melted chocolate. The funnel can be modeled by a cone whose radius is 6 centimeters and height is 13 centimeters. I'm already looking for a drawn to scale. 6 plus 6 is 12, and 13, that looks just a bit higher than 12, and 13 is just a bit longer than 12. So this is drawn to scale so far. The baker uses 2 cubic centimeters of chocolate to decorate each cookie. When the funnel is completely filled, what is the maximum number of cookies that can be decorated with melted chocolate? I would definitely take your time to do some correct math and see if you could actually get the right answer. So they did us a favor here and they made the radius 6. They often just make the diameter 6 to see if, or they give you the diameter and make you uh, make you find the radius, but they actually just gave us the radius. What can we do? We definitely need the volume of a cone. So we go to the formula sheet, and the volume of a cone is luckily given to us right here. So we got the volume of a cone. We need that. We clearly need that, right? So if we have the volume of a cone, we can get the volume of how much chocolate she gets. Okay? So we have R is equal to 6. We have the H is equal to 13. And we get the volume is equal to 4/3 pi R cubed. No, that's completely wrong. Wow, that just happened. I was thinking about the sphere problem a second ago. So 1/3 pi R squared H, right? Again, not deleting any edits, not deleting any mistakes, because I'm just gonna, although I did all the problems, so you shouldn't see any mistakes in any of the problems where I get the answer wrong. I literally have all the answers here and I verified them with the state documents. So, but I might make a faux pas when I misspeak or something. Whatever. We're not going to delete those. So 1/3 pi r squared h. So the volume is equal to 1/3 pi. R is 6 squared times 13. And let's find out what that is in numbers. And notice that I might be a student who doesn't know how to do this problem, but I know that this step would be necessary anyway. That's going to give me a ton of information already. You can't just start guessing because you don't know how to finish the problem. Math problems in Regents are not meant to be one-step problems. So what I would invite you to do is just take the first step. And after the first step, if you know how to take the next step, take the next step. And if you know how to take the next step, take the next step. And you might find that a problem that you didn't know how to do, you just absolutely know how to do. So 1/3 times pi times 6 squared times 13. I don't know. My fake student me says I don't know how to do this problem, but I know that I have to find the volume at some point anyway. So I got the volume, and I bring that over here. Now I have a new thing that I'm doing for students. I realize that this is a benefit to students because it fixes a lot of muscle memory issues. Some students round to the nearest tenth or the hundredth or the thousandth, always, no matter what, because their teacher told them to. And then the test says to round to this, and they round to the wrong thing. I found that a quick muscle memory fix is to always write all the digits that you found, 490.088454, and then to round as necessary. But I noticed that the volume is 490, and then it says that the baker uses 2 cubic centimeters of chocolate. They use 2 cubic centimeters of chocolate. That's not the volume. The volume is 490. That means that this answer is wrong. Not only that, this is the volume rounded to the nearest integer. Uh, Not only that, but if the baker uses 2 cubic centimeters, they're using more than 1 cubic centimeters. So the answer has to be less than 490. So it's not 735. So the answer is either 245 or it's 78. And I will tell you where some students do good work and then they still get choice one, which is incorrect. This is what happens when they forgot pi. Here's the thing: if they use 2 cubic centimeters of chocolate to decorate with each cookie, then they have to do V divided by the 2 cubic centimeters that they use for each cookie. That's 490 divided by 2, which is equal to 245. Look at that. A problem that students may not know how to do If they just start the problem, then they may find that they actually get to the right answer anyway. Uh, Eliminate 490 because it's the volume. Eliminate 735 because it's the answer has to be, in this case, smaller than the volume, because you're using more than 1 cubic centimeter per cookie. So it's either 245 or 78. And since you're using just 2 cubic centimeters, you might actually fall right into the logic of just dividing by that too. Even if you didn't know how to do it, you might be lying to yourself because you actually 100% did know how to do it. Most of the time, and I will tell you this as a former student of math, now a student of teaching, essentially, right? Um, Trying to continually improve my career and my tutoring skills. I, as a student of math, used to get to problems where I didn't know how to do it. I just started till I was done. Once I realized very early on that I didn't often know the exact path to get to the final answer. I just knew I knew a step. I knew how to take a step in the right direction. I just took any step, and the truth is, I found out that any step turned out to be almost always a step in the right direction. I just did, and that's my advice to you. Almost every time when you take a step in any direction, it is nearly guaranteed to be the right direction. Numero nueve, number 9, in circle O below, chords CT and BN intersect at point A. They sure do. Chords CB and NT are drawn. They sure are. Which statement is always true? NT over TA equals CB over BA. Angle BAC is congruent to angle ATN, and or NA over AB equals TA over AC, or BCA, angle BCA is congruent to angle NTA. Okay, so this is something worthwhile to know. Something worthwhile to know is that these two triangles are congruent. These two triangles are congruent. I'm not congruent, I said congruent, similar. These two triangles are similar. So triangle CAB is similar to triangle NAT. What's the proof? CA, angle ACB, subtends arc BT. And angle TNAB also subtends arc BT. Two inscribed angles subtending the same arc. Their angle measure, is half of the angle measure of BT. The same half. So they're the same number. So their measures are equal. So angle C and angle N are common. And then you could say the same thing about angle B and angle T. But instead, what I'm going to do is I'm going to recognize that angle CAB, and angle NAT are vertical angles, and vertical angles are congruent. So by the angle-angle postulate, these two triangles are similar. And I'm going to write the vertex order, C and N. This is my trick that students love. C and N, and A is the second vertex on both triangles, and B and T, that's the third vertex. And so I can eliminate very quickly um, uh, some of the answers. Now, suppose you didn't know how to do everything I just did, because I said I would do process of elimination for every single problem. But you assumed that this diagram is drawn to scale. And I will say this, or even better, you checked whether the diagram is drawn to scale. Circle O, it is a circle. See, all line segments are required to be drawn straight. Okay, so that you know that if a curve is not straight, it's not a straight line. So line segments are required to be drawn straight. So there's nothing that's falsifiable here. Nothing is falsifiable here. Therefore, the diagram is necessarily drawn to scale. So they said angle here, BAC, which is one of the vertical angles, is congruent to triangle ATN. That's this angle here. First off, angle T looks like it might be like 60, 70 degrees, whereas angle CAB, looks like it might be like 80 degrees. These are not congruent. Angle CAB looks bigger. Therefore, it probably is bigger in general. So this one is very likely to be incorrect. Okay. And in fact, we already said that vertical angles are congruent, and angle CAB, BAC, and ATN are not vertical angles. There's nothing forcing these to be congruent. You could actually prove that they're not congruent by messing around with the position of point T. if you move point T around, angle T doesn't change size because it still subtends arc CN. But angle CAB or BAC sure does change size. You can make it into a right angle. You can make it into a smaller acute angle. You can make it into an obtuse angle. You can't have an angle that changes size be the same size as an angle that doesn't change size. So these are definitely not congruent. In fact, more if you were able to do what I just said, you could actually just look at the numbers. Angle BAC is angle 2 in this triangle, in the left side triangle, and angle ATN is angle 3 in the right side triangle. 2 and 3 don't correspond to each other. Same thing here. Angle BCA, this is angle 1, and angle NTA, this is angle 3. Angle 1 and angle 3 don't correspond to each other, so this one's false. And for this, by the way, for the same reason, if you didn't know how to do the problem, but you assume the diagram is drawn to scale, angle C is a very small acute angle, angle T is a larger acute angle. So if you assume it's not drawn to scale, then it's true. Then 4 is false. But if you actually check that it's drawn to scale, as we did, then we've actually confirmed that it's drawn to scale. Therefore, C can't be congruent to T. In general. Now, how do we eliminate the other two? Now we actually compare numbers. NT 1 3 over TA 3 2 equals CB 1 3 and BA 3 2. Now the numbers in the numerators and the numbers in the denominators match. This is looking great. And also the numbers in the numerators match, the numbers in the denominators match. And the triangles that they correspond to also match. NT on the right side, TA on the right side, CB, so they match this way, and CB on the left side, and BA on the right side, left side, yes, so they match. NT and TA on the right side triangle, and CB and BA on the left side triangle. That's what I meant to say. Whereas this one, NA, that's 1 2, over AB, that's 2 3, is equal to TA, that's 2 3, over AC 1 2. Now the numbers don't match. The numbers in fact cross. Therefore, this equation can't be true. So that's wrong, and the answer is choice 1. Número 10, number 10. In the diagram below of triangle ABC, ray CBF is drawn. AB bisects angle FBD, and BD is perpendicular to AC. If the measure of angle C is 42 degrees, what is the measure of angle A? This is a problem where if you don't label, this is the problem. This is where I said, remember that I'm just going to show this again, the amount of writing that I did. I know it's blurry, but you're not expected to read this. You're expected to see that I wrote stuff. Remember, as a tutor, I've already done these problems an infinite number of times. I know how to do these problems, yet I still write stuff down. You can't get these problems if you don't write stuff. Especially if you don't actually train yourself to use all the information that they gave you. Ray CBF is drawn. That's definitely a ray. Triangle ABC is drawn as a triangle. Nothing's violated so far. AB, segment AB bisects BFD. Now that's the angle BFD, so that's the interesting part. That and that are congruent. Okay, I'm going to put a dash through those, and they look congruent. Okay. They look congruent. And BD perpendicular to AC. They look perpendicular. The measure of angle C is 42 degrees. 42 degrees, which is just slightly less than 45. That looks just about right, because BD looks slightly smaller than DC. In our 45, 45, 90 triangle, BD would be equal to DC. So this is looking so great. If you want to say that this diagram is not drawn to scale because you pulled out a protractor and it turns out that CB is actually 40 degrees, the difference between a 42-degree angle and a 40-degree angle is so small that if you drew them on a screen with software, the moire patterns would appear. That's small. If you do that on a computer screen, that's literally too small to matter. So these are drawn to scale. So now the question is, what is the measure of angle A? And now if I didn't know how to do the problem, I would immediately be saying it. So it's got to be less than 42. I confirmed that it's drawn to scale. I confirmed that it's drawn to scale. I have confirmed every detail. Therefore, the measure of angle A is strictly less than the measure of angle C. So the measure of angle A is strictly less than 42 degrees. I confirmed that it's not drawn to scale. If I didn't confirm that it's not drawn to scale, what I would be drawing is an X here, an X here, because I don't think that they're true. But now I confirmed that it's drawn to scale, so those are just plain wrong. So now then I might be able to make a guess from here. Does it look like a 24-degree angle, or does it look like a 33-degree angle? Now I might struggle with that. But me visually, I happen to know what a 30-degree angle looks like. Doesn't look 30. Doesn't look 30. Doesn't look bigger than 30. It looks smaller than 30. Because I know what a 30, 60, 90 triangle is. I've seen them so many times. So this one is looking bad to me. Fake student me is sticking towards question one, even if I didn't know how to do it. But how do you actually do it? So let's find out if my fake student me is correct. I would start doing angle chasing and line segment chasing, or whatever chasing I need to do. This is 48 degrees. This is here. So the measure of angle DBC is equal to 90 minus the measure of angle C. So equals 90 minus 42, which is equal to 48. So that's 48. Okay. If I call this X and X, okay, just for the moment, now I have 48 plus X is equal to 180. Subtract 48, and I got that 2X is equal to X plus X is 2X, right? Is 180 minus 48, 140, 132. Divide by 2, I get X is equal to 66 degrees. So that's 66, and that's 66. Okay. And that's 90. And then the measure of angle A is then equal to 180 minus that 90-degree angle, minus that 66-degree angle. And that's equal to, according to my calculator, now this is me simulating pulling out a calculator. I'm not going to pull out the calculator every single time because you don't need to see me pull out the calculator. But if I struggle with arithmetic, I know a lot of students who get to this point and still get it wrong. 180 minus 90 minus 66 is 24. And if it's a part 2 problem, I mean, you definitely want to put that in your calculator. But there's your answer, 24. Groovy? Notice that we confirmed the diagram is drawn to scale. Number 1 through number 10, every diagram is drawn to scale. And there's 35 or 37 problems in this test. What is there? 35 problems in this test. So this that's 2/7 of the problem. And every diagram is drawn to scale so far. So, número 11, number 11. In circle O below, OA equals 6. The measure of angle COA is 100. What is the area of the shaded sector? 10 pi, 26 pi, 10 pi over 3, or 26 pi over 3. I'm already gravitating far away from 10 pi over 3 since it's so small. Even if I didn't know how to do the problem, I'm gravitating very far away from 10 pi over 3. In fact, let's do some process of elimination. So the area of the circle is equal to pi r squared, which is equal to pi 6 squared, which is equal to 36 pi. Okay, is 36 pi here? No. Are there any numbers bigger than 36 pi? No. Okay, cool. But this looks like almost 3/4 of a circle. 3/4 of 36 pi is equal to 27 pi, according to my calculator. This is slightly under, I'm going to call this K. So let K equal the area of the sector, of shaded sector. So 3/4 of the circle is 27 pi, but 3/4 of the circle would leave 90 degrees remaining. So K is less than 27 pi, but only slightly so. Only slightly less. The only number that's slightly less than, only slightly less than 27 pi is 26 pi. This is looking terrible. This is way too small. And this is looking terrible. If I didn't know how to do it and I just did that to make estimates, notice I used correct math to eliminate all the choices. I didn't want to do it this way, but look, only slightly less. Those are 1 and 4 are definitely wrong at this point. So how do I actually do the problem? I know that this angle is 100 degrees, which means that this great angle is 360 minus 100, which is 260 degrees. And so the shaded region is in proportion to this angle. So I got 260 divided by 360, the measure of the full circle in degrees, is equal to, so 260 is the measure of the sector in degrees, 360 is the measure of the full circle in degrees, and this is equal to the measure of the sector in area divided by the area of the full circle in area, pi r squared. Again, so this is the part over whole proportionality relation. Proportionality relation. Part of the circle 260, whole circle 360, part circle k, whole circle pi r squared. So we got 260 over 360 is equal to k over 36 pi. Again, I used to not be a fan of cross multiplication, but now I am. It fixes a lot of intuition issues by just doing it. So we got 360k. K is equal to 36 pi times 260. Divide by 360. Divide by 360. Cross that out, and I get that k is equal to, this is where you go use your calculator, but if you happen to know some basic arithmetic methods, if I cross out the zeros, that's equivalent to dividing by 10. And so that's legal. And then the 36 and the 36, that's equivalent to just dividing by 36. And it simplifies to 26 pi. 26 pi. That's a problem. We didn't just turn it into a passing problem. We turned it into an ace problem. There's no way to get it wrong, even if we didn't know how to do it. If we just made the estimate. Oh, look at that subscribe button. No, I want to put that there. Number 12, number 12. In rectangle ABCD, diagonal AC is drawn. The measure of ACD, look, I'm gonna draw a shape eventually, but you should be doing a stronger shape. The measure of angle ACD is 37 degrees, and the length of BC is 7.6 centimeters. What is the length of AC to the nearest tenth of a centimeter? 4.6, 9.5, 10.1, 12.6. I don't think that most students would be able to do this problem or even gain any intuition on this problem if they didn't draw the diagram. There are things that you can do to be able to get some intuition on this. Like, for example, the vertices have to be named in order, A, B, C, D, which means that AC is not a side of the rectangle. That's where a lot of students mess up. They assume that AC is a side of the rectangle because they said it, or because they said AC. But that's a false assumption. In fact, if you happen to know that AC has to be a diagonal, then you immediately can cross out 4.6. But most students would not be able to get that unless they draw it out. Let me see if this makes it nice for me. Yes. Okay. So I have a nice rectangle. A, B, C, D. Now, let's see. The measure of angle ACD is 37 degrees. Let's hope. Now, I'm not required to, as a student, I'm not required to draw my own diagrams to scale because I'm not the test creator. The test creator also, as we know, is not required to draw the diagrams to scale, but we also found out that they almost always do. Okay, so but I don't do say the measure of angle ACD is 37 degrees. So this looks somewhat okay. And the length of BC, in other words, this angle would have to be 90 minus 37, which is equal to 53 degrees. So this is 53 degrees. And they want the measure of AC. They give us that BC is 7.6. This is a right angle. This is 53 degrees. And this is 37 degrees. The way I know that those measures are true is that the opposite sides of a rectangle are parallel, and so we have alternate interior angles. Alternate interior angles are congruent. So 53, 53, and 37, 37. Okay. So based on this diagram, not only do I know that BC is 7.6 centimeters, but AC is probably actually a good amount bigger than 7.6. So 9.5 as for fake student me is looking a lot worse now. In fact, for real tutor me, it's looking false. Whereas I might not have, I do have the answer because I did the work, right? As you know, I did all the work and I showed a lot of work. You see all that lovely work. But prior to doing the work, I might not have a whole bunch of intuition on it. I do happen to know that radical 2 over 2 is like 1.4. If I multiply 7.6 by 1.4, actually then 10.1 ends up being too small. But because that would put a minimum, assuming that the angle would be 45 degrees, then AC would be 7.6 radical 2 over 2. No, I'm sorry, 7.6 radical 2. So AC would be 7.6 radical 2. So if we extend the size of angle BCA, then AC grows. So AC is greater than 7.6 radical 2. That's correct math. 7.6 radical 2 is greater than, let me just make sure that that's true. 7.6 radical 2 is 10.74. For a second, I doubted myself. So, but if I doubted myself in real life, I would go to the calculator and confirm. So that AC, and this has to be, so AC is greater than 10.74. So now I know that 10.1 is actually just completely incorrect. But I do have to do the math, and that makes 9.5 also incorrect. But I do have to do the math. I am committing to doing the math for every single problem because you have to know how to do it. One, because you have to do the work on the part ones, like I said. But this is literally a part two problem. Delete the multiple choices. This is a part two problem, isn't it? So how do you actually do this problem? It's actually a cosine problem. So this is the side opposite to the 37-degree angle. And then AC, so BC is equal to the side opposite the 37-degree angle, and then AC is equal to the hypotenuse. Opposite leg over the hypotenuse is equal to cos theta. So we have 7.6 over AC is equal to sine of 37. If I cross multiply, put that over 1, okay, I have that 7.6 times 1 is equal to AC sine of 37, divide by sine of 37, divide by sine of 37. I get that AC is equal to, well, it's 7.6 times 1 over sine of 37. It's exactly equal to that. But now we get the approximation in decimal form. 7.6 divided by sine of 37. Make sure my mode is in degree mode. And as you know, my new muscle memory fixer is to write the whole number, is approximately 12.62846 46507. And now we round to the nearest tenth of a centimeter. 6 to 2 causes us to round down, 12.6, making 4 the correct answer. Notice that we actually eliminated 3 of the 4 choices. We turned a passing problem into an acing problem. Not bad. An acing problem, again, is a problem that you can't get wrong no matter what. And now, again, a passing problem is a problem that you've eliminated 2 out of 4 choices. Am I wrong? Definitely almost every problem that I've done so far, I've turned it into a passing problem. That's why my advice is super duper. And that's why I advise you to take the advice. Notice, though, I didn't eliminate answers that I just plain old thought was wrong. I eliminated the answers that I confirmed were 100% incorrect using correct math. So even if you don't know how to do a problem, there are, and this is without exaggeration, usually between 10 and like 50 ways of doing a problem correctly. But there are, and again, not an exaggeration, thousands of ways of determining which answers are incorrect using correct true math. And so that's why I'm suggesting that you don't just eliminate answers because you think they're wrong, although that's something you have to do sometimes, but you do correct math to eliminate some of the answers. Okay, número 13, number 13. A peanut butter manufacturer would like to use a cylindrical jar with a volume of 1,180 centimeters cubed. The jar has a height of 10 centimeters. What is the diameter of the jar to the nearest tenth of a centimeter? 3.8, 6.1, 10.9, and 12, or 12.3. Now, I mean, 10 centimeters, I know that we're going to be multiplying. I already know that this one's going to be too small before anything. I know that it's going to be too small. I crossed it out. I have no immediate intuition on 6.1, 10.9, and 12.3. But if I do pi r squared h, there's no way to use a 3.8 and a 10 to jump all the way. This is a diameter. Remember, this is the diameter here. They're asking for the diameter of the jar. So I guess I should be more clearer about that. There's no way to take a diameter 3.8 divided by 2 to get 1.9 and then square that with an h of 10 and multiply by pi and get all the way to 1,000. No way. So the answer's got to be 6.1, 10.9, or 12.3. So what do I do in this problem? I start by drawing the cylinder. And I notice that this one asks for the diameter. The previous one gave the radius. One thing that the Regents does is they think they make the problem harder by giving you or asking you for the diameter. And to be fair, they did make it tougher because a lot of students get it wrong the moment they ask for diameter because they get the radius and they stop. But another thing happens is with students who do so many problems and they actually get good at them that they see that they just keep asking for the diameter or giving the diameter, and they just start assuming that it's always the diameter, and then they get it wrong when they ask or give a radius. So do read the problem. Make sure you use the information that they gave you. The volume is equal to 1180. The height is 10 centimeters. So 1180 centimeter cubed, 1,180 centimeters cubed. And they want the diameter of the jar. But I'm going to get the radius first. Okay? So does the formula sheet have the volume of a cylinder? Yes. Can I get a better screenshot than this? Yes. Oh, I gotta scroll down. Okay. So the volume equals pi r squared h. I have r as a mystery number. I have h is equal to 10. H is equal to 10. So I have 1180 equals pi r squared times 10. So I divide by 10 pi. Now, another place where a lot of students get this wrong, divide by 10 pi, and they get r squared is equal to 1180 over 10 pi. They do the square root. They remember it's plus or minus, but they eliminate minus the negative sign because the radius is strictly greater than 0. Okay? But then they don't use parentheses when they plug it into the calculator. So they get to this point and they don't use parentheses when they plug it into the calculator. I want you to remember, and I'm an enemy of PEMDAS. I like this acronym better, GEDMSA. And if you're like, oh, PEMDAS is so easy to remember, but PEMDAS is also causing thousands, millions of students to get problems wrong. So G stands for grouping symbols. And why is that relevant? Because the horizontal fraction bar is a grouping symbol. The diagonal fraction bar isn't. So do you need parentheses when I wrote it on paper? No, because the horizontal fraction bar is a grouping symbol, grouping the denominator separately from the numerator. Do I need parentheses in the calculator when I type it in? I'm required to put in parentheses around the denominator because the denominator is not grouped. And I'll show you that that's the case. If I try 1180 divided by 10 pi, and I didn't use parentheses, I get that answer, and multiply by 2, and luckily that answer is not even anywhere remotely nearby. So I got lucky. But if it was a part 2 problem, I would lose my points. How about if I didn't do it that way? So radical 1180 divided by, with the required parentheses in the denominator, 10 pi. Now, why did I need the parentheses? Because in the problem, it's multiplying by pi. Without the parentheses, I do 1180 divided by 10, which is 118. Then multiply that by pi, that's 118 pi. This is 1180 divided by the number 10 pi. And I get 6.12. Actually, as I said, muscle memory fixer, I am going to bring in the entire decimal expression, 6.128667602, and then D is equal to 2 times that. Bring that here. Okay. What's going on here? It's acting funny. I'm going to delete that one. Did I paste it twice somehow? Okay. 12.2573352. And now if you think that it's a waste of time to write all those decimals, I've timed it even during a video. It takes 6 seconds to write that. So, and the test is 3 hours long. 3 hours is 180 minutes. 180 times 60 is what? Like 10,000 and something seconds. You have 10,000 and something seconds and you spent 6 seconds writing that number to guarantee that you're going to round it correctly to the nearest tenth of a centimeter. This 2 requires, the 5 after the 2 requires the 2 to go up. So 12.3. Notice that the units aren't there. They said, since they said to the nearest tenth of a centimeter, you don't need the units. And in fact, I'm going to recommend that you don't use the units when you're not 100% required to use them. How do you know when you're 100% required to use them? If they tell you that you have to give the units. That's when you know you're 100% required to use the units. Another one is like if they give you units, but you know you have to convert the units. In that situation, then you need to convert the units. All right? And give the units. All right, numero 14, number 14. Triangle KLM is dilated by a scale factor of 3 to map onto triangle DRS. Which statement is not always true? Angle K congruent to angle D, angle M congruent to 1/3 DS, or side KM rather, or area of triangle DRS is 3 times the area of triangle KLM, or the perimeter of DRS is 3 times the perimeter of triangle KLM. So if you actually draw this triangle, let's just draw a generic triangle. Okay. I'm actually gonna redraw that triangle. Let me see if it lets me draw. Ooh, if it lets me draw an obtuse triangle, just so that we don't think that they're always. Okay. So a triangle that doesn't look isosceles if we dilate this by a scale factor of 3, can I move this? Let me see. Okay. This is not, I'm gonna go the sloppy way. Gonna go the sloppy way. So boom, boom, boom. Let's see if it draws it out for me. Nice. Okay. So if I dilate this by a scale factor of 3, then this triangle is gonna, the new triangle is gonna be 3 times as big. Now I'm not gonna make this one nice. Oops. 3 times as big. 3 times as big. I need to make it 3 times as big. So 2, 3. That's pretty big. And then 1, 2, 3. There. Now I'm dilating this one around one of the vertices on the triangle, but I don't have to do it that way. I could do it from anywhere else. So now I'm going to take this other triangle. I'm just going to move it over here so that we can see them. So one thing that to know is that, well, so if I say that this is K, L, and M in that order, then that means that the dilation is mapped onto DRS. That means that has to be in that order, D, R, and S, in that order. So it has to go K, L, M, 1, 2, 3, 1, 2, 3. So it has to go in that order, 1, 2, 3, DRS, 1, 2, 3. Okay? So now, just based on that, K congruent to D, K congruent to D, they're saying not always true. K corresponds to D, and dilations preserve angles. So this is always true. So now how about these other ones? Km is a third of ds. Km is a third of ds. This bottom side corresponds to this bottom side. Well, they correspond to each other, and ds was dilated from Km was dilated by a scale factor of 3 to make ds. So ds is 3 times as big as Km. So Km is 1/3 the size of ds. So this is always true. And so that one's wrong. And now I got a passing problem. I have a passing problem because I have a 1 in 2 chance of getting it right. Is the area of triangle DRS 3 times the area of KLM, or is the perimeter of DRS 3 times the perimeter of KLM? Now, I might not know how to do this problem, but I might remember the linear square cube law and be able to answer the question. But if I can't answer the question, I might at least test one of these facts. And I suppose I made up numbers for these sides. So 10, let's say that this is 15, and then the top can't be 25, but maybe 20. And I triple that, 30, 45, and 60. And I calculate the perimeter. The perimeter of DRS in this case is, if I just made up these numbers, 45. No. The perimeter of KLM is 45. And the perimeter of DRS is 45 plus 60 plus 30, which is 135, which is 3 times the area of KLM. I'm sorry. I drew that on the area side. 135. No, yeah, 135 and 45. 135 is 3 times 45. So that one's actually looking good. So I might not be sure of the problem, but notice I just took some test numbers and found out that it actually makes a lot of sense. Now there's the linear square. I said I would tell you how to do every single problem. There's the linear square cube law. Now, you might have heard of the square cube law in like YouTube videos, but the linear square cube law is more specific. And this one says that if a dilation, after a dilation by a scale factor of, let's say, k, all linear terms, all linear quantities, they're multiplied by k. all so all linear properties, these are lengths. All the square properties, these are the areas. The areas these are multiplied by k squared. And the cube is the volumes. All volumes are multiplied by, after you multiply by a scale factor of k, all volumes are multiplied by k cubed. Notice, by the way, that the exponent of these numbers are actually the dimension of the quantities. Linear quantities, lengths are one-dimensional, areas are two-dimensional, and volumes are three-dimensional. And that's actually not a coincidence. That's, in fact, the definition of dimension. That's the definition of dimension. So now we know actually not only that, but now we know how to define dimension. So what does that mean? Perimeter is a length. So perimeter is multiplied by 3 to the 1, which is equal to 3. The area is multiplied by 3 squared, which is equal to 9, not 3. So the answer is, in fact, choice. I'm sorry, I misspoke. No, I didn't misspeak on any of what I just said. I misspoke on the answer because this is always true. And this is actually, in this case, always false. It's not only not always true, it's actually always false. Because 3 is not 9. Groovy. All right. Número 15, number 15. A rectangle with dimensions 4 feet by 7 feet is continuously rotated about one of its 4-foot sides. The resulting three-dimensional object is a cylinder with a height of 7 feet and a base of radius of 4 feet, or a cylinder with a height of 4 feet and a base radius of 7 feet, or a cone with a height of 7 feet and a base radius of 7 feet, or a cone with a height of 4 feet and a base radius of 7 feet. Well, I would really just sit and think about what this problem is asking. This problem is going to be asked in every single Regents problem, and every single Regents exam, and actually, this actually matches an extremely important problem that exists in calculus. So this is even considered to be pre-calculus. You have to know what you get when you rotate a point around a line. When you rotate a single point around a line, you get a circle. Well, what does that mean? Well, a rectangle is made of points. That means that all points on the rectangle form a circle of that radius. So if we take a rectangle dimensions by 4 feet by 7 feet, okay, slightly longer than it is wide, good. So that's 7 and 4, okay? And now we're going to rotate continuously around one of its 4-foot sides, okay? So rotate around one of its 4-foot sides. So what happens when we rotate around that 4-foot side? We're actually going to get, this point is going to make a circle around that red line. Three-dimensional, coming out of the page. Three-dimensional coming out of the page. And then this line, that line right here, can't see it, it's rotated, rotated, right to here. What shape is that? So you can actually see what shape this is already. To get a cone, you have to start with something that comes to a point. In other words, you have to have something that rotates but doesn't move, which means it has to be on the line of rotation. And it has to come to a point. If you rotate a triangle, or like an isosceles triangle around its altitude, then you're going to get a cone. But you're always going to get a circular shape. This one has somewhat circular shapes. It's made up of a bunch of circles. But sometimes they'll literally have things like, oh, cube, no, or oh, triangle, or rectangular prism, things like that. Out of a rotation, not going to happen. You're going to get here a cylinder. Now, so cone can be definitely crossed out. Now the question is, do you get a cylinder with a height of 4 feet and a base of 7 feet, radius of 7 feet, or do you get a cylinder with a height of 7 feet and a base radius of 4 feet? Well, this height is 4. So this is also 4. And that height right down the middle is also 4. So the height of is 4 feet. And the base radius is, this is the radius right here. And that radius gets rotated around. And the radius stays constantly 7, 7. So that does make sense. The answer is dose 2. Super de duper. Number 16. Número 16. In right triangle ABC, altitude CD is drawn to hypotenuse AB. If AD is 4, CD is 8, the length of AB is, of BD rather, is radical 48, radical 80, 12, or 16. I mean, this is another one. Again, if you just draw it out, you're going to be closer to being able to get the answer. If you don't draw it out, then you're up a creek without a paddle. So right triangle ABC, altitude CD is drawn to hypotenuse AB. So they tell you that AB is the hypotenuse, which means that if I draw, let me see if I could actually draw a right triangle and if it'll fix it for me. Nice. I'll take it. Okay, so they said the hypotenuse is AB. And then so the right angle is C. And then they said that AD, altitude CD is drawn. So this is the one that has to go to this side and it has to be perpendicular. Just do your best to make it perpendicular. That's point D. So AD is 4 and CD is 8. Now, this is not drawn to scale. So definitely because the 8 looks shorter than the 4. But luckily, you have an eraser, and what I have is the technology. So I'm going to make it so that the bottom, this shrinks this way, okay? So that this is going to be A, C, B, and now I draw altitude D, okay? And this is looking a lot better, okay? And that can't move that. So I have that AD is 4 and CD is 8. Now they want the length of BD. Well, now I could do, I could actually use drawn to scale because I redrew the diagram and made it drawn to scale. DB, BD is longer than CD, visually speaking. I drew it to scale. AD, this looks like a right triangle, for sure. This looks perpendicular, for sure. AD looks half of CD. In fact, I could even make it shorter so that DB would be bigger than that, even that. So not only is DB bigger than 8, but it's actually probably quite significantly larger than 8. So, but it's longer than 8. Radical 48 is around 6.9. That's not it. Radical 80 is around 8.9. Radical 81 is 9. It might even round up to 9. This is around 7. This is around 9, right? So those are not the answers. They're too small. DB is significantly shorter than CD. So it's either 12 or 16. Now, I might not trust my drawing ability, so I might not be willing to stick between 12 and 16, although it does make it look like DB is a lot longer than CD, so 16 is looking nice to me, but I might not know. Either way, it's a passing problem because I've eliminated 2 choices just by drawing it to scale. That's literally all I did. I drew it to scale. Instantly, 2 of the choices got eliminated. So how do I do it? Now, this is the hard part that a lot of students get to. Here's the thing to know: when you drop an altitude from the right angle of a triangle, you actually create 3 similar right triangles, which means that the sides are all in proportion, and then you can actually create a proportions. So how am I going to do that? I'm going to number these 1, 2, 3 in black, okay? And I'm going to make what I call the cheat code. And I name these vertices in the order that I just wrote them, okay? So it goes 1, 2, 3. It's the right angle C. The angle A is the second angle. Angle B is the third angle of the outside triangle. This is the outside. Now the left side triangle, I have to figure out which vertices correspond. So vertices correspond to C, A, and B. They has to go in that order of the right angle first. So this has to be vertex 1 of the right side of the left side triangle, because that's where the right angle of the left side triangle is. So it has to go D. And then A has to correspond to A for the outside triangle, because A corresponds to itself, which means that the only remaining vertex of the left side triangle is vertex C. So this is 2 for the left side triangle, and this is 3 for the left side triangle. Okay. Now, on the right side, again, the right angle, this is the right side triangle, which is similar to the other two triangles also. The right angle has to be number 1, because for the outside triangle, the right angle was number 1. C. Now, I might not know which vertex corresponds to A on the right side triangle, but I know that B corresponds to itself. And B, so this has to be the third vertex for the right side triangle, which means that vertex C for the right side triangle has to be the second vertex. I miswrote that. D, let me repeat that, so let me just be clear. D is the right angle for the right side. I might not know which vertex corresponds to A on the outside triangle, but I know that B corresponds to itself. So B has to be the third vertex. Therefore, C has to be the second vertex. And now I have the cheat code for every proportion that I can write. Now I have 2 sides of the left side triangle, and I have 1 side plus I need a second side of the right side triangle. So the cheat code is going to allow me to write a proportion that I could solve. That's the purpose of creating this cheat code. So I know that might be difficult, but now that I wrote the cheat code, I can create a proportion. AD over another known side of the left side triangle, CD. Now this went 2, 1, and CD, this is 3, 1. This has to be equal to, on the right side triangle, now I have to go 2, 1 over 3, 1. So it's written for me already. 2, 1 is CD over 3, 1 BD. And that's my proportion. And therefore, I could plug in numbers. I have 4 over 8 is equal to 8 over BD. Do the cross multiplication, which I used to hate, but now I love. I got 4 BD is equal to 8 times 8, which is 64, divided by 4. So divide by 4, and I get that BD. According to my calculator, 8 times 8 divided by 4 is 16. That was a tougher problem. I'm hoping that you got something out of it. That's the way I've been tutoring it recently, and it's been working. It's a longer process than what other teachers have taught, but the difference between, the way I teach it and the way I tutor it I do teach it this way too, but the difference between teaching and tutoring is that often I could teach it to you one time. I need to find a way that I could teach it to you one time and it sticks to you. This tends to stick to students when I teach it once. So that's why I do it that way. So if that helped you, hit the like button. Do subscribe. Look, the reason I asked for subscriptions, by the way, is I've at this point I used to tutor for like very low money, $10 an hour. Now I tutor and this is, don't quote me on this because obviously a video is one time and it's permanent, whereas prices change. Right now my price is between 200 and 250 an hour, which is a whole lot of money. And I've priced out kids who look like me and lived like me when I was a kid. So I do this partially because I want to do something that is free, that everyone can access. And I want to create a video that's as good as humanly possible for everyone to enjoy and do as well as possible on the test. So if you feel that this so far has been the goat of explanations, process of elimination, and how to do every single problem. Granted, I made a few faux pas, but definitely, if you this is the goat of all videos that you've seen so far, write that this is the goat of all videos in the comments, and I would appreciate your subscription. That helps me to fund this part of my tutoring business. Número 17, number 17. If ABCD is a parallelogram, which additional information is sufficient to prove that ABCD is a rectangle? So I'm going to draw a parallelogram. Let me see if it fixes it for me. Nice. It is a parallelogram, and I'm also going to draw a rectangle. I'm going to draw both of them. And it drew that for me too. Nice. A, B, C, D. Do I want to modify this one? Let me see if I make it a little bit wider to make it more parallelogrammy. Okay. And A, B, C, D. So let's see, which one would prove that ABCD is a rectangle? So if AB is congruent to BC, well, AB does not need to be congruent to BC, right? That would make it a, what would that make it? So that wouldn't modify the angles. So these angles could still be acute or obtuse. So this can't be it. Notice that my process of elimination is literally drawing it out. So this might fix the problem for us. AB is parallel to CD. Already, I could eliminate that because that's already true. Now, how about AC is congruent to BD or AC is perpendicular to BD? Now, this is interesting. This is where I might struggle as a student, but I've already done process of elimination and eliminated two answers. I put the X over here, but it actually belongs there. I don't know which one of these right now is true, so but I've turned it into a passing problem. But which one is true? I'm actually going to draw A, C, and B, D. Now, a lot of students would get this one wrong because they don't draw it out. That one's too bendy for them to fix it. They don't draw it out, so they start to think that maybe AC is a side and BD is a side of the parallelogram, when in fact, if you draw it out, you realize that AC and BD are diagonals. Okay, so which one makes this a rectangle? If AC is congruent to BD or if AC is perpendicular to BD? So if AB is congruent to BC, we realize that this is a rhombus because it doesn't modify the angle, but it makes all four sides congruent. AB is already parallel to CD if this is already true. Now, if AC is congruent to BD, right now AC is not congruent to BD, versus if AC is perpendicular to BD. Actually, if I draw a rhombus this way, let's see if it fixes it for me. Nice. I'm liking the software. I didn't test it. I didn't test that before. I did test the straight line drawing. I've been using it for a while, but I didn't think it would draw the shapes nicely for me. That's weird. But if I draw it this way, okay, that one went too curly and it's not fixing it. and this way, then I see that these are perpendicular, right? So in a rhombus, diagonals are perpendicular. And this is definitely not a rectangle, but it is a rhombus. So this number 4 makes it a rhombus. My process of elimination eliminated choice 1 and 2, but now additional thought eliminated choice 4. But in a rectangle, if you actually draw this out, you realize that this has to be true. Why does this have to be true? Because a rectangle has 180-degree rotational symmetry. Is that good enough? No, that's not good enough at all. A rectangle has a line of reflection. And if a rectangle has a line of reflection, can I make that black? Let me see. Nope. If a rectangle has a line of reflection that's vertical, when you reflect it over that line of reflection, dB will be reflected onto AC, which means that AC is congruent to BD. So in a rectangle, the diagonals are congruent. So it is number 17. Número 17. That's it. It is choice 3. All right. Número 18, number 18. Line segment APB has endpoints A, -5, 4, and B, 7, -4. What are the coordinates of P if AP to PB is in the ratio of 1 to 3? Is it -2, 2, or -1, 1.3, or is it 1, 0, or is it 4, 2? This is I'm always debating whether using this graph paper scrap is worth it. It is because why? Because it is worth it. You know, that's not the question whether it's worth it or not. I've noticed when students go to use their scrap paper. Hold on, we'll go there. When students go to use the scrap paper, they end up not drawing things accurately. My advice, if you're going to use the scrap paper, when you're graphing, you have to graph accurately. Okay, that's the only condition that is required for scrap paper for graphs. Okay, so I'm going to draw this y-axis. Okay, I'm going to do this in blue because I know 10% of the boys watching this video are colorblind and would have trouble seeing that red. Fun fact, I'm colorblind. So that's the x-axis, that's the y-axis. So I have APB has endpoints A, -5, 4. 1, 2, 3, 4, -5, and 4. So that's A. And then B, 7, -4. And this is going to be where using a straight edge is extremely wise. If you do this, this is why the graph using the scrap is actually also wise. That's I would suggest using the scrap paper. I mean, I think it has to do more with weird pedagogical things that I've noticed with myself that's breaking my intuition. But there's no good reason not to use the graph scrap paper. So I think from now on, I'm going to actually say, go ahead and use the scrap paper. Now, if I actually draw the line segment from A to B, now that I have my straight edge, I could do that. Now I can actually graph these choices. -2, 2, -2, 2, that's 1. -1, 1.3, which is not exactly there, but this is choice 2. Choice 3 is 1, 0, which is that point, C, not C, 3. And then choice 4 is 4, -2, is that point. Now, interestingly, a lot of times when they do this, they actually make it so that one of the points is not even on the line segment, but happens to be able to be found using incorrect math. Um, Incorrect math, right? So the question is now AP to PB, AP to PB is equal to 1 to 3, which means that P has to be closer to A than to B, which means that eliminates choice 3, which is the midpoint, eliminates B, because this would be a ratio of 3 to 1 in that order, and it's either choice 1 or choice 2. So choice 3 and choice 4 eliminated, and just by graphing it, we have a passing problem. Okay, so how do you actually do this problem? How do you do this problem? So one way is, and I'm going to do this the multiple choice way. I go down 2 and over 3, and I go down 2 and over 3, so -2 and 3, and I go down 2 and over 3, and I'm going to go down 2 and over 3. Now I did that 4 times, so this is 1x, and this is 3x over here. I did that 3 times. So that ratio is 1 to 3. So the answer is choice 1. Now, how do people get 2? How do students get 2? Because they end up accidentally doing a ratio of 1 to 2. In other words, they do part over the whole is equal to, they do part over the whole equals 1 over 3, when it's actually part over part equals 1 over 3. I've done this in other geometry videos and other methods. So if you want to see another method, watch my other geometry videos. For now, on numero 19, number 19, in the diagram below, AB and CD intersect at E. They sure do. And CA and DB are drawn. They're just drawn. If CA is parallel to BD, okay, then which statement is always true? Now, this is again, do you know how to determine what's true about different shapes? By making these parallel, first off, these are going to be congruent because, and they're looking for always true. Those are going to be congruent because they're vertical angles. Do they ask that? Unfortunately not. But by making CA and BD parallel, they are making these triangles, this angle and this angle, congruent. And they're making this angle, which looks like a right angle, but they didn't say anything is perpendicular. So I can't say that they're perpendicular, but those are congruent. So triangle CAE is similar to triangle DBE by the angle postulate. And now let's see where my process of elimination leads me. AE congruent to BE, CA congruent to DB, triangle AEC similar to triangle BED, or triangle AEC congruent to triangle BED. Now here's the thing about, again, we talked about drawn to scale. This diagram is drawn to scale, except that it still has a degree of freedom. And the degree of freedom is that I could pull CA to the left as far as I want, and I could pull BD. Also, up to similarity, it has 1 degree of freedom, and up to congruence, it has 2 degrees of freedom. I could pull CA to the left as far as I want, and I could pull BD as far as I want. So up to congruence, it has 2 degrees of freedom. Up to similarity, it has, up to congruence, it has 2 degrees of freedom, and up to similarity, it has 1 degree of freedom. So it's still free to be such that the triangles are bigger than they actually are drawn. So the diagram is not, in this case, drawn to scale because of the fact that the triangles don't need to be the same size. Nothing is forcing them to be the same size. So as a result, a lot of students do get choice 4, but since no lengths are restricted, this has to be wrong. And in fact, for the same reasons, these have to be wrong. So these are also wrong. Now, there is another way to eliminate all the answers that I discussed in my notes, and it's this. These are similar by the angle-angle postulate. If any other length is congruent, are congruent, then the triangles would be congruent, which would make choice 4 true. So if 1 was true, that would imply that choice 4 is true. That would imply that choice 2 is true. They can't all be true. Similarly, if choice 2 was true, that would imply that choice 4 is true, which then would imply that choice 1 is true. They can't all be true. Again, if choice 4 is always true, that would imply choice 1 and choice 2 are also always true, and they can't all be true. If you have a situation where a bunch of answers are true simultaneously, then and they can't be all true simultaneously because it's I'm sorry. If it's you're ever in a situation where where a bunch of answers are simultaneously correct at the same time, then they are all incorrect because it's a proper multiple choice question. So choice 1, 2, and 4 are also incorrect because if any of them were correct, they would all be correct. Therefore, the only answer is remaining is choice 3. So we have two ways of doing number 19, and we're down to numero 20, number 20. If sine of 3x plus 9 is cosine of 5x minus 7, what is the value of x? They didn't eliminate this question from the test because it's a multiple choice question, but it has a flaw. And those of you who are comfortable with your trig may know what the flaw is. The flaw is that there's an infinite number of answers for x. Since sine is periodic, sine of 3x plus 9 is periodic. Cosine of pi x 5 cosine is periodic. You put a linear function in there, cosine of 5x minus 7 is also periodic. Since they're both periodic, they're going to be equal to each other an infinite number of times. That said, only one of these answers is valid. Now, I'm going to use my random number generator. I haven't yet had to do this because there's not much random plugging into this test, but I always choose one random choice to be the one that I plug into, and the one that I plug into according to my random number generator is going to be choice 3. So I'm going to randomly, oh, I didn't circle it. I'm going to randomly plug in choice 3 to test if it's correct. This is a calculator doable problem. You could plug in every single answer until you find that you get the same number. Sine of 3 times 33 plus 9, close. I got 0.951, sure, okay. And I got cosine of 5 times 33 minus 7. If I get the same number, then that's the answer. I do not get the same number. Not only that, they're not, the one is the negative of the other. So that's not the answer. So I could choose another number to plug in, choose 1, 2, and 4, plug in. One of them is going to say that the left side and the right side are equal to each other. And it turns out that this one and this one gives you the wrong answer. But I promised that I would do every single one algebraically, at least, using standard methods. Here's my a standard fact. Sine and cosine are cofunctions. Therefore, sine of 90 minus theta is equal to cos theta, and cos of 90 minus theta is equal to sine theta. Sine of 3x plus 9 would be equal to cos of 90 minus parentheses 3x plus 9, and that's also equal to cos of 5x minus 7. Okay, so now we're hoping here that this works out. Again, I think the best way to do this problem is plugging in, but if this is true, we can hope that the insides of these are equal. We hope that 90 minus, well, they are equal. They can be equal, but there's an infinite number of answers. 5x minus 7. If we distribute this number, we get 90 minus 3x minus 9 equals 5x minus 7. Okay. And then if we combine these terms, We get 81 minus 3x equals 5x minus 7 plus 7 plus 7. Let's put this over here. We get 88 minus 3x equals 5x plus 3x plus 3x equal, and we get 88 equals 2x. No, 88 equals 8x. Divide by 8, and we end up with x equaling 11. So we, again, there is a certain amount of luck that just happened there. Unfortunately, the best way to do this problem is plugging in and checking. And it is important to know that this is not only a problem that can be done on the calculator, but it is a calculator problem. Number 20 is a calculator problem. Since there is an infinite number of choices, it is not just theoretically, but numerically possible that you try something using correct math and then you end up getting an incorrect answer because it doesn't appear on the list. In other words, you get an answer that would be correct if it were on the list, but it's not on the list. But if they said something like get an answer that and it was a part 2 question, then what you would do that way algebraically would be what you have to do. So the reason I did do this is, again, well, because this could be a part 2 question. Okay. All right. Numero 21, number 21. Which set of integers could represent the lengths of sides of an isosceles triangle? 113, 225, 336, or 447? Clearly, all of these have two sides that are congruent. So there has to be something that's violated from these. And if you actually try to draw these out, try to draw length 1 and a length 1 and a length 3. That's not possible. That would imply that if you decided to go to your friend's house, it's 3 miles away, but instead of going straight to your friend's house, you went to your friend, like if this is Alice and this is Juan's, and you're going to Juan's house, but instead of going to Juan's house first, you go to Billy's house. But going from Billy's house to Juan's house somehow is shorter than just going straight to Juan's house. That's physically impossible. So that's exactly what we're testing here. 1 plus 1 equals 2, which is less than 3. 2 plus 2 equals 4, which is less than 5. That's physically impossible. 3 plus 3 equals 6. Now this, as a walk, is theoretically possible because maybe Billy's house is on the way to Juan's house. But then it's not a triangle. That would be a degenerate triangle, literally a line segment. But this one, 447, gives a valid triangle. So this is the triangle inequality. I'll give you the simplest version of this triangle inequality. The sum of the two shortest sides must be greater than the largest side. Of a triangle. And that's actually the only requirement that the lengths of a triangle have to satisfy in order to be a defined triangle. Just that. All right, number 22, number 22. In the diagram showed below, altitude CD is drawn to the hypotenuse of right triangle ABC. Which equation can always be used to find the length of AC? This is the cheat code again. Outside, left, and side, and right side. And if I go for the outside vertices, 1, 2, 3, C, A, B. Then for the left side, I know that the right angle is at D. So D has to be, I'm going to do this one, I'm going to underline this in blue. D has to be the first vertex because that's where the right angle is on the left side. Then A has to correspond to A. So the only remaining vertex has to be the blank, B, C. 1, 2, 3. And then for the right side triangle, I'm going to underline this one in black. The right angle has to be on bottom again because it's the right angle has to be 1 because it corresponds to the right angle on the outside triangle, D. I don't know which one corresponds to A, but B has to correspond to it has to be the third vertex, and B corresponds to itself, so B. So B has to correspond to itself, and B is the third vertex, so B is number 3. And then the second vertex has to be C, right in the middle. And that's my cheat code. And so then I see which of these proportions is basically contained in the cheat code. Now, in order to eliminate choices, when I'm making a proportion, I have to make proportions using only 2 triangles. So maybe I can get lucky and some of the proportions use more than 2 triangles. So I see, for example, AC, CD, CD, AD. Now, AD is is a side of only the left side triangle. So now I know I have to use the left side triangle. AD, and that's 3, 1. Now, CD is not 3, 1. I'm sorry, it is 3, 1. AD is 2, 1 for the left side triangle. Okay. And so it's also CD is also 2, 3 for the left side triangle. It's 3, 2. So now on this triangle, the only other triangle that this belongs to is CD. CD belongs to the outside triangle. So now we have to go to the outside triangle. CD, this is 1, 2. No, the outside triangle. Sorry, CD. CD is part of the right side triangle. So now the only other triangle that we could be using is the right side triangle. This is the right side triangle, CD. This is 2, 1. And then AC is not part of the right side triangle. Okay. There is another method of eliminating choices that I tend to like, and I tend to just do a quick look at big and small, and that helps to eliminate some choices. CD over, and I don't know if this will help with specifically 2 or 3 or 4, but let's see, CD over AC. So there's nothing in this diagram that could be violated because everything that is a right angle looks like a right angle. So the 3 triangles are similar. If I have CD over AC, CD over AC, that's small over big. And then I have AC over AB, that's small over big. Now, this one, AC over CB, AC over CB, that's a bigger side over a smaller side. And then I have CD over BC, that's a small side over a big side. So this is big over small, making this fraction bigger than 1. And this CD over BC, that's small over big, that's a fraction less than 1. So we got this is greater than 1, and then 1 is greater than this. This can't be true. Okay. So which of these is then the true one? So well, we have to actually just continue to investigate. Unfortunately, that's the only way to do it. CD over AC equals AC over AB. So but we could actually eliminate one of the triangles by noticing that both of these ratios have AC in them. I'm going to erase these numbers so that they're not in our way for explanation for 2. AC and AC are both part of the left side triangle and the right side triangle. Then CD is part of the left side triangle. So this is 1, 3. And on the left side, I'm going to make that in blue. Sorry, 3, 1. 3, 1. And then AC on the left side triangle is 2, 3. And then on the uh, outside triangle, AC, this is 2, 1. Over AB, this is 3, 1. The numbers don't match. So this is not it. So the answer is choice 4. Going through it that way, I don't know. I don't know if there's a faster way to necessarily go through it. I will say this, that sometimes you get lucky. There is a standard one that they love using, like AD over DC equals DC over DB. And you just this over this equals that over this. And they love doing that one, and that one is true. So you could just look to see if you get lucky and it's one of the choices, but it's not in this case. So I'm not sure if there's a faster way to do that one. All right. Número 23, number 23. Which congruent statement is sufficient to prove parallelogram mark is a rhombus? Very similar to the one that they just did, isn't it? So what we do, we draw a parallelogram that is definitely not a rhombus, and then we draw a rhombus. Okay, so this one, let's see if we can make this one a rhombus by making the sides shorter. Okay. And then this one will make it very more parallelogram-y by making it a bit longer. Okay. And then we label A, B, C, D. So, or M-A-R-K. M-A-R-K. I'm not a fan of this problem being in the test because they literally made two problems that are nearly identical. This one and the rectangle one. You know, repeat problems. That means that they're testing fewer skills. That means that technically that's a 4-point problem, isn't it? And if you happen to know how to do that problem, great. Now you're in a good place. And if you happen to not know how to do that one problem, now you're in a worse place. So I think the Regents makers have to be better at making their tests and testing more things. It literally makes the test easier by testing more things because it allows you to have more skills. Because after all, they're not testing easier skills and making it more likely that you pass. No, they're testing the same difficulty skills. Just so they're making it so that your test varies more, essentially. Like the standard deviation of test scores grows by doing this, but does nothing to the average. That's not good. For students who are like around a 65, you don't want a bigger standard deviation because if you can get yourself to a more guaranteed, more likely average 70 or 75, if your standard deviation is low, then your probability of passing is just greater. If you're trying to get a 90 and the standard deviation is low, then your probability of getting a 90 is greater, as opposed to getting, or closer to a 90 is greater, as opposed to getting like an 80 accidentally, you know? So that's my philosophy. So let's see which one would be prove that parallelogram mark is a rhombus if MA is congruent to MK. That's looking good, because MA for a rhombus is congruent to MK. But the second one, let's see, if MA is congruent to KR, that's actually already true. And if angle K is congruent to angle A, that's actually already true. And then if angle R is congruent to angle A, that's not already true. But what this would do is it doesn't change lengths of sides. And a rhombus is a parallelogram with 4 congruent sides. So this is likely not the case. This one, we already eliminated that, so we've already turned it into a passing problem. But R congruent to A makes it a rectangle, which is decidedly not necessarily a rhombus. Not necessarily. So actually the one that looks good is the one that is true, because what this does, a parallelogram already has 2 pairs of congruent sides, and MA congruent to MK makes it that it has 4 pairs of congruent sides. 4 congruent sides. All right, número 24, number 24. A line whose equation is y equals negative 2x plus 3 is dilated by a scale factor of 4 center at 0, 3. Which equation represents the image of a line after the line after the dilation? They love asking this question. It's almost like I wonder if you should just assume that this question is going to be on the test. This is a dilation of a line through a point on the line. So we have 0, 3, slope negative 2. Let me draw that in blue. Slope negative 2. Okay. And that's the y-intercept, 0, 3. And it's dilated around the point 0, 3. So when you dilate a line around a point in the line through a point on the line, that means that the line is preserved. The line is preserved. All it does is shrink an infinitely long line in the direction of that point. But if you shrink an infinitely long line, it's still an infinitely long line. So like this point will be dilated down to this point. This x-intercept will be dilated to that point right there, but it'll be just dilated in towards 0, 3, but the line will not change location. So the equation has to remain the same. But now for process of elimination, I said that I would do process of elimination first. And the thing is that dilations preserve parallelism. So that would imply that the slope doesn't change. The slope doesn't change. So that's wrong, that's wrong. Now we have a passing problem. So process of elimination. But in fact, the whole equation in this case doesn't change. So it's choice 1. Okay? So we've done every single problem. We've done process of elimination, and almost every single problem, we turned it into a passing problem. So if you do appreciate that literally I just got you to pass the test. And if you actually know how to do some of the problems beyond turning some of them into a passing problem, then not only do you get a 65, but you can get a 70, 75. Now, I showed you that almost all of these questions were part two questions if you just delete the multiple choice. The same thing happens with the part 2s. You could just add multiple choices and it turns into a part 1. So a couple of things about this: include necessary steps, including appropriate formulas, substitutions, diagrams, and graphs and charts. You do have to show work here. Number 2, utilize the information provided. Of course, you should utilize all the information provided. In fact, you should assume that all the information is relevant. And then number 3, note that diagrams are not necessarily drawn to scale. You know what I do. I cross it out. That's not the best cross out. I'm gonna move that. I cross it out. Why is it not letting me move it? Okay. Note that diagrams are not necessarily drawn to scale. Cross that out. There you go. And for this part, a correct numerical answer will receive only 1 credit. So if you could figure out how to do the problem on the calculator, just give the answer, you get a point. And you might say that's not worth it, but notice that that's half a multiple choice question. 1 point is half a multiple choice question. A full correct part 2 question is a full multiple choice question for free. So you need about 13 to 14 multiple choices to pass the test. Remember, I said a passing question is one where you have a 50-50 chance of getting it right, because then you would get 12 right if you did that with every question. But the truth is that if you just know a little bit of geometry and turn a whole bunch of other questions into a passing problem, you passed. But showing work on those means if you show the work on those and you show the work on the part 2s, 3s, and 4s, you should actually be able to get to an 80. The reason I actually know, besides the fact that when I grade the Regents, I look at the part 1s and I look at the work students do it, and it's usually none. the reason I know that students didn't do their work besides the grade what tests that I grade, and I do grade every season, except usually August now, is that there should theoretically be a gap, a giant gap between students who get a 65 and students who get an 80. There shouldn't be any students in that region. Why should there be no students in that region? Because the students who are barely passing focus on the multiple choice and either get a 65 or maybe a little bit above or below. But then they don't do anything on the part 2, 3, and 4 because they don't show work. And then but if those students did show work, there's almost no reason that they should even get a 65. If they can get a 65, they can get an 80. And that's why there should be a gap between a 65 and an 80, statistically speaking, and there's not. So most students don't show work on the part 1s. So if you show work on the part 1s, you do better relative to other students. You do better relative to other students, okay? So, numero 25, number 25, and the triangle ABC below, the measure of angle C is 90, sure, looks like it. AC is 11, looks nothing contradicting that. AB is 18, slightly, almost, even approaching double the length of AC, which 18 does approach double 8 to 11, which is 22. So that looks good so far. Determine and state the measure of angle A to the nearest degree. So this diagram is basically, it's drawn to scale, so we could start assuming, we could start making an estimate. Slightly more than 45 degrees. There's my estimate. Maybe 50. Now, I don't know if it's slightly more or less than 50, but that's my estimate, 50. How do we do this, though? They said the measure of angle A. Now, notice that this is the leg adjacent to angle A. And this is the hypotenuse. So cosine of A is equal to the adjacent leg over the hypotenuse. So cos A is equal to 11 over 18. So that A, how do you invert cosine? There is no division by cosine. It's inverting cosine. Cos inverse of 11 over 18. And if you don't know where cos inverse is on your calculator, it is there. If you know where cosine is on your calculator, it's here for a second. So cosine is right there. In blue, what looks like a -1 exponent, that's cos inverse in blue. So you press the blue second button and then press cos inverse, and then 11 over 18, close parentheses. And now this is where the muscle memory fix is relevant. This is where I tell students, let me get this over here. You can go ahead and time me, but I've already timed myself in a video how long it takes me to write this. So A is approximately 52.330111304. And then I go A is approximately, then I look for what they said to round to. They said nearest degree, and then 50, and so the 3 goes to 0, 52. $52. I don't even have to give the degree symbol. So I'm just gonna give 52. I'm gonna explain now why I don't give the symbol. Because they gave the units. Since they gave the units, you don't have to give the units. Okay? So we get that. All right. Number 26, numero 26. So this is one that I'm not going to do on the screen. Use a compass and straight edge to construct an equilateral triangle inscribed in the circle A below. Leave all construction marks. This is, there's something, I've been thinking about doing a video. I gotta sign into something. I've been thinking about doing a video that I've been calling, in my own mind, I've been calling it construction kung fu. Construction kung fu, the reason I've been calling construction kung fu is that there's just a series of transformations that you just have to know how to do. And if you learn how to do those transformations, then you basically know how to do those every other transformation. And not only that, if you do those transformations, you can literally do every other transformation. Like, and it all, and you could, well, so if you do those transformations, you could do literally every other transformation. What am I talking? Sorry. Let me re-clarify. If you do those constructions, you could do every other construction. And not only that, you could actually get to the point where you could do those constructions in like 20 seconds. So you literally can get to the point where you can do 20 seconds of constructions, and every single construction problem is doable. So how do I do this problem? One way, I'm going to show you two ways. One way is my favorite construction. That circle. Notice that circle has the same radius as the original circle, because it's literally this line segment is a radius of both circles. Therefore, they're the same size. So if I actually now use this point over here and draw a circle here, and now use this point and draw a circle here, this is my favorite construction. And now use this point here and draw a circle to the center, and use this point again and draw a circle to the center, and finally use this point and draw a circle to the center. This is my favorite construction. It just looks really cool, in my opinion. And not only that, you actually have enough information here to construct a regular hexagon inscribed in the circle, because these points here are separated by 60 degrees. So, but if they're separated by 60 degrees, that would mean that if I draw this line segment here, let's say this line segment from here to here, and this line segment from here to here, and this line segment from here to here, I now have an equilateral triangle inscribed in the bigger circle. So my favorite construction happens to create an equilateral triangle transcribed in the circle. But there's another one. There's another version of this one, so that I was taught more recently. It's simpler, but it doesn't involve my favorite construction. So if you actually use these two lines, these 2 points, to draw a big line. And for teachers, by the way, and for students also, why am I doing this on software? Well, I found that if you actually use the compass is just a drawing tool. So you literally put the needle down and you put the pencil down, and you either rotate the compass or you rotate the paper to draw a circle. And then the straight edge is just a tool to draw straight lines. I've found that if students just learn how to do constructions on the screen, it immediately transfers to drawing them on paper, because all the compass becomes is a thing to draw lines, and all the straight edge becomes is all the compass becomes is a thing to draw circles, and all the straight edge becomes is a thing to draw lines. So I draw this line going through it, and then I have this point up here, and I draw just a single circle from the top to the center of the circle, and I have these 2 points. Now, it's not necessarily obvious why these 2 points is all I need, but if I draw this to that, that to that, that to that, that to that, that is also an inscribed equilateral triangle. So this one is clearly a lot simpler. Which one's better? I actually, as my students know, I never call any one method better or worse than another, because they're better in one situation versus another situation. Like, my construction allows you to construct an equilateral or a regular hexagon, and allows you to construct a whole lot of other things. There's perpendicular lines that you could use what I just did to construct lots of other things that you could construct via what I just did. But of course, this diagram looks a lot simpler. So I guess whichever you like better is the one you can do. So I'm gonna take a screenshot and bring that over, and that's how to do número 26, number 26. Okay, but número 27, number 27, quadrilateral deer and its image, quadrilateral d prime, e prime, a prime, r prime, are graphed on the set of axes below. Describe a sequence of transformations, excuse me, that grabs quadrilateral DEAR onto quadrilateral D prime, E prime, A prime, R prime. Let me get a sip of water, or coffee rather. So how do I do this transformation? There, I'll tell you this, I used to teach it a certain way, and only recently have I decided to teach it and tutor it a different way. Because remember, I have to show you one time in a way that will stick to you forever. And I don't get to correct any mental errors, so I only get to tell you one time. So I found that despite the fact that for teachers and many students, once they get used to it, there's one set of transformations that is their most intuitive. There is one that works really well for even students who struggle with the intuition. Here's step one. And step one will always be a transformation, a translation. Step one is always going to be a translation. So what am I going to do with this translation? I'm going to translate 1 point onto a corresponding point. Okay? I'm going to translate 1 point onto a corresponding point. So I'm going to translate DEAR. I'm going to translate, I want to translate D to point D prime. Okay? So I'm going to translate 7 units down and 2 units right. You could use your notation, your fancy notation, T sub -7, nope, 2 comma, the x direction first, comma, -7. You could use that fancy notation, but you don't have to. But if you like that stuff, sure. Then the second step, once I do that, well, let me actually do that. So I got D prime, D double prime now. This is now D double prime also. D prime is also D double prime. R prime goes down 7 and over 2. This is R double prime. And A double prime, 1, 2, 3, 4, 5, 6, 7, and over 2. This is A prime, double prime. And then 3 below that is E double prime. And if you notice, you might actually realize that the rest of the transformation is actually a little bit intuitive, isn't it? Let me try that. Draw it again. Let me see if I can move that line segment up. There we go. So you might notice that the rest of it is actually kind of intuitive, because if you look at it, these actually are mirror images of each other. So what's the benefit of this? It actually, by doing step one, always that first, it usually is the case that the very next step is more obvious. If you have to rotate 180 degrees around that common point now, usually you could see that. If you have to rotate 90 degrees either clockwise or counterclockwise, you could usually see that. And if you have to reflect, usually you could even see the line of reflection. And what's the last one? If you have to dilate, you could usually see the dilation factor too. So step one, that's the best step one. Out of all the steps in the whole world, that's the best step one. Because step two now, I actually see that I just reflect over the vertical line, y equals 2, x equals 2. X equals 2. So x equals 2 is this line over here. Reflect over that line. And I have d prime, e prime, a prime, r prime. And that's my reflection. So now notice that they said describe. That is a description. You just have to use words. You can use your symbols if you wanted to add that. R sub x equals 2. But I do have to use words because they did say describe. Okay? So my recommendation to get your points, and by the way, if you just say step 1, you already got a point. Why is that worth it then? Why is it worth it to always do that one first? Because you automatically get a point just by getting that one right, even if your second step is wrong. And it's usually obvious how far to translate from one corresponding number point to another. D to D prime, it's down 7 and over 2. Count 7, count 2. Down 7 over 2. All right. Number 28. Número 28. Encircle P below tangent AL and secant AKE are drawn. If AK is 12, and KE is 36, determine and state the length of AL. Well, I don't know, but I mean, it almost looks like twice as long as AK. So my estimate, first off, is this drawn to scale? Does KE look 3 times as big as AK? It actually does look about 3 times as big as AK. So this is drawn to scale. And my estimate, I mean, AL looks about twice as big as AK. So I'm going to say AL is approximately 24. Maybe. I mean, if it's 24, then another 12 would make it as long as KE. That does make sense. That's my estimate. By the way, if you just wrote 24, you'd get lucky. Because remember, this section says if you just wrote the number, you get points. Now, there's a lot of incorrect methods that get you to 24. What is the theorem? The theorem is this. The product, the outer secant times the whole secant. So these meet at point A. So you have to have a secant and a tangent intersecting. The outer secant times the whole secant is equal to the tangent squared because they meet at the same point. It's also true that if you have 2 secants meeting at A, then the outer secant of 1 times the whole secant of 1 is equal to the outer secant of the second one times the whole secant of the second one. But it's also equal to the tangent squared. Notice, by the way, that this happens to imply that if you have 2 secants intersect, 2 tangents, if you have 2 tangents intersecting at the same point, they have to be congruent. Secants, not so much. 2 tangents, yes. So anyway, so if I plug in some numbers here, this is another place where a lot of students get it wrong. This is AK times, this is where the students get it wrong. They say the whole secant, but then they mislabel it. It's actually AE. What do students usually say if they got it wrong? They say KE. The inner secant, but it's not the inner secant, it's the whole secant. Outer secant times whole secant equals tangent squared. And so this is equal to AL squared. And so if I plug in some numbers, 12 times 12 plus 36 is equal to AL squared. So I got 576 equals AL squared. Take the square root of both sides, take the square root of both sides, bring in the plus or minus, and then we reject the negative. Why do we reject the negative? Because AL is greater than 0. AL is a length, so it's greater. AL is a length of a physical line, so it's greater than 0. So AL, and we go to our calculator, is, I'm not going to simulate this every time. You go to your calculator, radical 576 is 24. Groovy. 2 points. Free multiple choice question. If you make a mistake on this one, like, so for example, you use an incorrect theorem, but you do the math and you get an answer, you could get a point. So is it worth doing a part 2s? Yes. For those of you who are saying focus on the part 1s, focus on the part 1s, you focus on the part 1s by doing the part 2s. Because one part 2 is a multiple choice. And you really can't get, if you're focusing on the part 2s, but you're not showing work on the part 1s. I'm sorry, if you're focusing on the part 1s, but you're not showing work on the part 2s, you're not focusing on the part 1s. You're focusing on the part 1s with quotation marks that have to be there because it's a lie, right? So you actually have to focus on the part 1s by doing the part 2s. Take my advice, because that button says subscribe. Numero 29, number 29. Oh, by the way, my subscriber count is 761 as of the making of this video. So between the making of the last video and the making of this video, I gained a subscriber. Woo! So, but my goal is to get to 30,000. My temporary goal is to get to 1,000. So if you want to help me get to my goal while I'm helping you get to your goal, please do hit the subscribe button. I don't put out a lot of videos, so you're not going to be bombarded with videos that you don't like. But it helps me to get to my goals. All right, number 29. The equation of a circle is x squared plus y squared plus 8x minus 6y equals 7, plus 7 equals 0. Determine and state the coordinates of the center and the length of the radius of the circle. Okay, so this is a algebra 1 skill multiplied by 2 to a geometry skill. How is it multiplied by 2? It's completing the square twice. So x squared plus y squared plus 8x minus 6y plus 7 equals 0. We're going to subtract 7 from both sides. So the step is get the variable terms alone on one side and constant alone on the other side. So we get, and we leave a gap there. We're going to write x squared plus 8x, leave a gap, plus y squared minus 6y, leave a gap, equals negative 7. Okay? Right? Number 2, then you're going to write b over 2. Actually, this is not really step 2 because this is step 3. Make sure the coefficient of x squared and y squared is 1, which it already is. Okay, so that's done and that's done. Now step 3, write b over 2 and b over 2 squared for x and y. So this is the completing the square. This is the completing the square. So we're going to write x and y. And so b for x is equal to the coefficient of x, 8. B over 2 is equal to 4. B over 2 squared is equal to 16. And for y, b is negative 6. B over 2 is equal to negative 3. And b over 2 squared. Love you guys if you think that negative 3 squared is negative 9, but it's not. It's not. Because you need parentheses. Negative 3 squared is 9. You need parentheses. And if you don't believe that you need parentheses, let me just convince you once and for all, maybe, that you need parentheses. Let's say you don't put parentheses. Negative 3 squared is negative 9. And it's like, what the heck? You get a different answer. And then you might be saying to yourself, well, which one's right? Well, let me answer that and prove that the 9 is right. You're allowed to put parentheses around any number you want. So you're allowed to put parentheses around the negative 3. Therefore, the negative 3 with parentheses squared equals 9 has to be correct. So why is the other one incorrect? Because it's not 9. That's it. So 9. And then step 4 of this, add b over 2 squared to both sides for both x and y. So that's what we're going to do. We're going to add b over 2 squared plus 16 and plus 9 plus 9. And you might say, why did we do that? Well, because we've completed the square. That is the square now completed. Step 5 is factor as a perfect square. Square. Squares. Using b over 2. Using b over 2. So this, the first term is equal to x plus b over 2, which is plus 4, squared, plus y plus b over 2, which is plus negative 3 or minus 3, squared. That's equal to negative 7 plus 16 plus 9. Use your calculator is 18. Got x plus 4 squared plus y minus 3 squared equals 18. Determine the coordinates of the center and the length of the radius. The center, so remember this is x minus h squared plus y minus k squared equals r squared. Two places where students lose points. They forget that h and k are being subtracted from x. The centers are being subtracted from x and y, and the radius is being squared. So the center is negative 4, comma, positive 3, and then the radius is equal to the square root of 18. R squared equals 18, square root, plus or minus, reject with negative sign because r is greater than 0, so r equals radical 18. This is easily a part 1 question with multiple choices, like for the center negative 4, 3, or 4, negative 3, and then r maybe either 18 and radical 18, or maybe 9 and radical 18, you know, that kind of thing. Multiple choice question, a 2 by 2. Okay. Number 30, número 30, on the set of axes below, triangle ABC is drawn with vertices that have coordinates A, 2, negative 3, B, 4, 5, and C, negative 5, 1. Determine and state the area of triangle ABC. This one has so many ways to do it. It actually became a little bit of a running joke when we were norming how to do this test. We do the problems, and I ended up just finding one way after the other, after the other, after the other of doing this problem. But there are 2 standard methods of doing this, and I want to show you the 2 standard methods. But I want to tell you that there are more than one method. In fact, I found the last one that I found is this one. Just break the triangle up into 2 parts. But since that's not always so easy, since that's not always so easy like that, I'm going to show you the very standard method is to draw the smallest rectangle possible around this triangle. Okay, so now what we have is admittedly a rectangle, or a triangle that may be hard to get the area of, but also a rectangle that's easy to get the area of, and a few triangles whose area is also easy to get. So this length here is 1, 2, 3, 4, 5, 6, 7, 8, 9. This length here is 8. This length here is 2. This length here is 7. This length here is 4. This length here is 4. Okay, so I'm going to call this area, I'm going to call the area of triangle ABC, I'm going to call it K. Okay? And I'm going to call the area of the other triangles L, M, and N. Notice that the areas of K, L, M, and N combine to make the area of the outer rectangle. So the area of the outer rectangle equals K plus L plus M plus N. Now, K right now is a difficult number to get, and that's what they want us to get. They want us to get this K, the area of triangle ABC. But it turns out that the area of the outer rectangle and L, M, and N are all doable, because the outer rectangle, going to the bottom of the sheet, it's there. Where'd the formula sheet go? Did I close it? Oh no, I didn't close it. I had this open. Going to the formula sheet, we have the area of a triangle. The area of a triangle is 1/2 base times height. And also, you might not like that the rectangle area is here, but it is right there because a rectangle is a parallelogram. So let me bring that over so it's not being blocked. Base times height. So I'm going to bring that over. Let's bring that here. Okay. Makes that a little smaller. There we go. So the area of the outer rectangle, according to this, is base times height, which is 9 times 8. And that's equal to K, which is a mystery number, and that's okay, because now the area of L has a base of 9 and a height of 4. So 1/2 9 times 4 plus M has a base of 7 and a height of 4. So 1/2 times 7 times 4. And then N has a base of 2 and a height of 8. So plus 1/2 2 times 8. And if we do this arithmetic on the calculator, we get 72 equals K plus 1/2 times 9 times 4 is 18. Plus 1/2 times 7 times 4 is 14. Plus 1/2 times 2 times 8 is 8. And if we subtract 18, subtract 14, subtract 8, we get that K on your calculator is equal to I'm just confirming. Let's see. 20, 28, 32, 30. Yes, I just wanted to confirm. I got scared for a second. 32. So that's K. There are a lot of ways of doing it. You could break up K into 3 triangles interiorly. And then you could actually, in this case, you get lucky because you could draw a horizontal line from K to AB, which will stop here. And then you broke the K triangle ABC into 2 triangles, one on top, one on bottom, one with a base of, well, actually, they happen to both, by coincidence, have a base of 8 and a height of 4. Notice I didn't give units. Well, actually, they didn't give units either, but if they give the units, you don't have to give units, okay? So here, number 31, numero 32, in the diagram below, AE equals 15, EB equals 27, AF is 20, and FC is 36. Explain why EF is parallel to BC. So we're going to prove that EF is parallel to BC. You could do this via a statement reason proof, but we have to remember the side splitter theorem. And if we actually do the proportion of the pieces, you don't have to do it by the side splitter theorem. You could also do it by similar triangles, but in the correct order. But if you do 15 over 27, so this is AE over EB is equal to 15 over 27. And if you do this on your calculator, you can simplify this. Let me show you how to simplify a fraction on the calculator. This is a big deal. You do 15 over 27. If you go to math, press the math button, the very first option is arrow frac, means convert to fraction. And that simplifies it for you, 5/9. And then if you do the same thing for AF over FC, AF over FC, that's equal to 20 over 36. And if they have a common factor of 4, or again, you could simplify it on your calculator, 20 over 36. Math, convert to fraction, 5/9. And now you have to say words. Since these are the conditions of the side splitter theorem, or the converse of the side splitter theorem. So since EF splits segment AB and AC into proportional segments, you have that EF. That's the conditions of the side splitter theorem converse. EF is parallel to BC. That's it. If you did the algebra, you would get a point. You do need the sentence, okay? Because it does say explain. Okay. Número 32, number 32. Again, the same deals. Utilize all the information. Show all work. Clearly indicate all necessary steps. That's super necessary. I cross out that note that diagrams are not necessarily drawn to scale. Because if you notice, there was only one diagram that was only technically not drawn to scale, in that the triangles could be made any size. In other words, there was a degree of freedom remaining that made the triangles, even though they drew them looking congruent, they weren't actually necessarily congruent. So that one was the first one in this test that was not necessarily drawn to scale. But under the definition that if a figure has a degree of freedom that can make scale change, then it's not drawn to scale. Okay. If you use a different definition that says it's only not drawn to scale if things that have to be a certain proportion are strictly not that, then under that definition it is drawn to scale. But I would say that one's not drawn to scale because of the fact that there is a degree of freedom that can change scale. All right, número 32, and then finally, if you just give a number, if you find a number, you get a point. Okay, so número 32, number 32, building is composed of a rectangular pyramid on top of a rectangular prism. As shown in the diagram below, the rectangular prism has a length of 38 feet, a width of 15 feet, and a height of 22 feet. So 38, 15, 22, that looks about right. A rectangular pyramid sits directly on top of the rectangular prism, and its height is 12 feet. That looks about right relative to the 22. Okay. An air purification filter was installed that will clean all the air in the building at a rate of 2,400 cubic feet per minute. Determine and state how long it will take to the nearest tenth of a minute for the filter to clean the air contained in the building. There are problems with the wording of the problem here. I will say that, because if you happen to know about what it means to clean all the air, but you're assuming that air that goes into the filter comes out and stays clean somewhere else. That's the weird part. Okay. So clearly we need to know the volume. So if you get the volume, you get partial credit. So what's the volume? This is a rectangular prism. And this is a rectangular pyramid. This is 38. This is 22. Okay. And so if you go to your formula sheet, the volume of a rectangular prism and a rectangular pyramid are here. Here's a general prism. And so a general prism says that the base could be literally anything. And a rectangular pyramid, A general pyramid said that also says that the base could be anything, any flat two-dimensional shape, any flat shape. Okay, so now we have the volumes of these two pieces, and so the volume of the bottom part, the rectangular prism, would be 15 times 38 times 22, plus the volume of the top is the 1/3. Don't forget the 1/3 times. Oops, and I misspoke here. 15 here. 15 times 38 times 12. Okay. Lots of places to lose little points here. Like I just switched the 22s and the 15. That's actually one of my common errors, but I fixed it. Uh, Students mess up those kinds of things all the time, and unfortunately, even though that's not, I don't consider that to be a careless error. I actually tell students there's no such thing as a careless error, despite the fact that the error could be fixed with carefulness. Carefulness is not the opposite of carelessness in the case of when a fix can be done through carefulness. It's not the same thing. Okay, so if we plug in some numbers here, we go on the calculator and we get 14820 for the volume. Notice I didn't give units. I did have to check the units, and I didn't do that before, but let me do that now. They said the length is 38 feet, the width is 15 feet, and the height is 22 feet. And the height of the pyramid is 12 feet. So all the units are given in feet, and the volume is now in cubic feet. Cubic feet. So I do have to remember that. And now the air purification filter was installed, so that will clean the house, the building, at a rate of 2,400 cubic feet per minute. So how long will it take to the nearest tenth of a minute for the filtration system to clean the air? So the number of minutes is equal to the volume divided by the volume per minute. That's equal to 14820 divided by 2,400. Well, let's get that on the calculator. And remember what I said, I actually recommend now writing the whole thing, 14820 divided by 2400. And your calculator says 6.175. So this equals to 6.175, equals exactly that. And that's approximately equal to, now we go to the round to what they said, nearest tenth of a minute. 6.7 causes you to round up. That's a 2. Okay. 6.2 minutes. Notice I didn't give units again. If they gave the units, you don't have to give the units. I've seen students get this completely right and then mess up the units and lose the points there. Okay. Número 33, number 33. I recommend for students who don't know how to do proofs, and quotation marks don't know how to do proofs, I recommend doing this problem anyway, because the moment you write even just one correct statement, you get a point. So if you write one correct statement, you might find that you could actually, one correct statement beyond the givens, then you might find that you could actually just keep going and write more correct statements and more and more and more correct statements. So that's why I recommend doing this. Okay. So I'm gonna write just before even getting started. That was a very unstraight line. There you go. Reason. Okay. 1. So given triangle ABC and triangle DEF, and AB is perpendicular to BC, and DE is perpendicular to EF, and AE is congruent to DB, and AC is parallel to FD, woo, that's a lot. Prove that triangle ABC is congruent to triangle DEF. I'd recommend to students labeling what they said. So first, I'm going to write the givens. Triangle ABC, triangle DEF. Now AB is perpendicular to BC, and also DE is perpendicular to EF. And then AE is congruent to DB, and AC is parallel to FD. Wow. And 1, that's given. So that's a required part of all proofs. You have to write the givens. Now, I'm going to label everything that they just said. There's something that you need to know. AB is perpendicular to BC. A lot of students mess up because they see this right angle symbol and they think, oh, now you know it's a right angle. This is not a right angle symbol. It's a perpendicular symbol. It just happens to be that perpendicular lines form right angles, so we borrow it for right angles. But when you're doing a proof, you actually have to state that they're right angles. That if you've made congruent right angles, you actually have to state that. We've just labeled perpendicular. We did not label right angles. And what else? DE, perpendicular to EF, and AE congruent to DB, and AC parallel to FD. Okay. So one thing, I need to prove that these triangles ABC, 1, 2, 3, congruent to DEF, 1, 2, 3. I like seeing parallel lines because the moment I see parallel lines with a single transversal, I already know that I have congruent angles by alternate interior angles or alternate exterior angles or corresponding angles, or I have maybe supplementary angles. And in this case, since I'm trying to prove two triangles congruent, I have congruent angles. So angle A congruent to angle D. If you notice, AC is parallel to FD with transversal AD. That makes a Z, and alternate interior angles make a Z. So alternate interior angles are congruent. Okay? I don't have to say that when they're made by parallel lines because I've already stated that the lines are parallel. So now I've already got a point on this problem. Half a multiple choice. If I could give even one more correct statement, now I got 2 points. And then the rest of the points are a little harder to get until I complete. But if you do complete the proof but make one mistake, that might be just 1 point off. You might get 3 points. That's 1.5 multiple choice questions. So don't reject the proofs even if you struggle with them. If table proofs just don't ever work for you, maybe think about doing a paragraph proof. Anyway, so what else did I say? I saw perpendicular lines. I remember that my tutor, Juan, says perpendicular lines form congruent right angles. But perpendicular lines and labeling it perpendicular is not the same thing as labeling it a right angle. So I have to say that the angles are congruent right angles. So angle CBA, I'm actually going to use, I have to now think about which one I'm going to use, but I don't have to, but I know I'm going to use side angle side. So, let me think. I'm going to split it into 2 because that's one way to do it. There is a way to write it in 1 step, but the drawback to writing it in 1 step is that sometimes you need. No, you know what? I'm going to write it in 1 step. You don't actually need it. So let me just say it. The right angles are congruent. So angle CBA is congruent to angle FED. Okay? And the reason is that perpendicular lines form congruent right angles. They do allow that. Perfect. So I have 2 angles congruent. So chances are I'm going to finish this proof with either angle side or angle side angle. Nothing is telling me that FD is congruent to AC. Nothing is telling me that CB is congruent to FE. But I see that AE is congruent to BD, and both of those share EB. So I have to state that EB is congruent to itself. By the reflexive property. Because now that that it's congruent to itself, I can add that piece to these 2 congruent segments, AE and BD. So the statement is that AB is congruent to DE is that I've added AEB to AE, and I've added EB to BD. So the segment addition postulate. And now I have one pair of angles, another pair of angles, the right angles, and then a side, which is the included side of those two angles, angle E, angle D, and side ED, that's the included side. So that's angle, side, angle. So 6 by angle, side, angle, triangle ABC is congruent to triangle DEF by angle, side, angle postulate. You could just say angle, side, angle, they'll accept that. There we go. 4 points, 2 multiple choices. That by focusing on this part three, I've focused on the multiple choice. That's 2 multiple choices that I just did. If I had just gotten one extra thing, which is a nice one that all of you can get, the moment you have two parallel sides, you can get congruent angles, alternate interior angles congruent, or you can get supplementary angles for a lot of reasons. If you have 2 crossing sides, you can get vertical angles congruent. There's a lot of things that you could do. And the moment you start giving more information, that's true, the more points you get. Now, this is the one problem that I said that we might have to fight Kumite style to decide if this diagram is drawn to scale or not. Might have to get my boxing gloves ready. Let's read the problem first. In the diagram below, a boat at point A is traveling towards the most powerful waterfall in North America. Here's the boat at point A, traveling to the most powerful waterfall in North America, the Horseshoe Falls, which, by the way, looks a lot like Niagara Falls on the Canada side, but this is a bigger one. The Horseshoe Falls has a vertical drop of 188 feet, and the angle of elevation from point A to the top of the water is 15 degrees. After the boat travels towards the falls, the angle of elevation at point B to the top of the waterfalls is 23 feet, 23 degrees. So now this one, I wish I had a white pen. Do I? I don't know what that pen does. Let's see if I could get a light blue. Oh, there we go. 23 degrees. 23 degrees. Okay. Determine and state to the nearest foot the distance the boat travels from point A to point B. Now, this is where we have to maybe fight a little bit. Maybe I need to get my boxing gloves, right? Or something. But see, I argue that this diagram is drawn to scale. But people who say that this diagram is drawn to scale are right. And people who say this diagram is not drawn to scale are also right. How could it possibly be that they're both right? The people who say this diagram is drawn to scale are including the background, and they see that the boat is going in 3 dimensions in kind of that direction, right? Into the page a little bit, right? Going that direction. Whereas people who say the diagram is not drawn to scale ignore the background, and the moment you ignore the background, you have this funny triangle. That's a little extreme. It's not that extreme. You have this funny triangle that looks like that, and then like that, and then like that, like that. But then this is a right angle, clearly drawn obtuse. So the people who ignore the background say it's not drawn to scale, and people who don't ignore the background say it is drawn to scale. So it's kind of that red, blue, or black or white and gold dress situation. It literally is like that. I see the background, so I see drawn to scale. But even if it's not drawn to scale, it happens to be that these angles are actually nice and forgiving, because a 15-degree angle and a 23-degree angle are actually pretty small angles, which makes the distance from point A to point B estimatable and comparable to 188. So my guess right here, my estimate, is that AB is comparable to 188. Now, my own personal intuition says that AB is probably going to be longer than 188, but um, that's my own personal intuition, and I really don't have a good reason other than the fact that I could manipulate this visually in my head. So what do I do here? I mark this vertex just to have a vertex C, and I mark this vertex D. Okay, so we're looking for AB. How do we get AB? Well, actually, we can't get AB in one step, but if you do follow and you follow the order of operations in get something, you might find that you could get something else, and then you might find that you could just finish the problem. So AB is equal to, no, AC is equal to the leg adjacent to the 15-degree angle. And also CD is equal to the leg opposite to the 15-degree angle. This means that tan 15, which is equal to opposite leg over the adjacent leg, that's equal to the opposite leg is CD over AC. So I have tan 15 is equal to CD, which is 188, over AC. I'm going to put this over 1 to do my cross multiplication, which I'm a fan of now, as I said before. So I got that AC is equal to 180, AC tan 15 is equal to 188, divide by tan 15, divide by tan 15, and I get that AC is equal to 188 over tan 15. Now, I am actually going to leave it that way for now. In this case, just to show you that there's an alternative way of organizing the work. But what I've seen a lot of students do is put that in the calculator now. And you could absolutely do that. Just make sure to save. In this case, you really want to save all your digits. Okay? So if you do it that way. Now, for the angle that's 23 degrees, I have that BC is equal to the leg adjacent to the 23 degree angle. And I have that CD is equal to the leg opposite to the 23 degree angle. So therefore, tan 23 is equal to CD over BC, which is equal to 188 over BC. So I have tan 23 equals 188 over BC. Put the tan 23 over 1 so I can cross multiply. I got 188 is equal to BC tan 23. And if I divide by tan 23, I get that BC is equal to 188 over tan 23. Now, if leaving it this way, if leaving AC as 188 over tan 15 confuses you, then put it in the calculator and get decimals. If leaving BC as 188 over tan 23 also confuses you, then put it in the calculator, get your decimals. But now that I know that I know AC and BC, I can get AB. So AB is equal to the long AC minus that piece that's extra, BC. So I get that this is equal to 188 over tan 15 minus 188 over tan 23. And I get that on my calculator. Okay. 188 over tan 15. Now, tan 15 is a smaller number, so dividing by a smaller number results in a bigger number. So 188 over tan 15 should be a bigger number. That's good. Minus 188 over tan 23. That was just me checking my answer. And I get 258.72 and a whole bunch of decimals, right? So AB is approximately 258.725307. And so AB is approximately, then I go back to what it said, to the nearest foot. So the 7 causes me to round up. So I get 259, and everything was in feet, so I'm done. They gave the units, so I don't have to give units. That's good. So, number 35, número 35. Now, as I was saying before, if I earned your subscription, please do subscribe. My subscribe count as of the making of this video is 761. My temporary goal is 1,000. My eventual goal is 30,000. But if you feel that this has been the GOAT of review videos, say it in the comments. Just say this video is the GOAT. If not, just say hi. But definitely do appreciate the subscribe. But I'm gonna go into this, and I'm gonna point out this piece right here. 6 credits. Do you really want to skip a 6 credit problem? The moment you skip a 6 credit problem, your max grade is already a 94. So if you think that you're just trying to pass and you're skipping the 6 credit problem, your math you should think about what the math looks like at that point, because what ends up happening in that case is that you're actually not playing the 65 game out of 100. You're playing the 65 game out of 94, and it might seem like that's the same game anyway because you're going from the bottom up to 65, but that's not really how the math works. It's not really how the math works. A 65 out of 94 is equivalent to a 71 out of 100. So if you skip on purpose part 4, you're literally hoping to get a 71 just to pass. That's really how the math works. Is it 71 out of 100? Did I lie? 2/3? No, more like a 69. A 69 out of 100. A 65 out of 94 is like a 69 out of 100. So now you're aiming for a 69. You're not even aiming for a 65. Is it really worth fighting it? Focus on this. You could easily get some partial credit here. You might find that this problem you could actually get a ton of partial credit. Clearly indicate the necessary steps, including appropriate formula, substitution diagrams, etc. Note the diagrams are not necessarily drawn to scale. I always cross that out for students, and I have them do it because diagrams are. You saw that there was one diagram that technically wasn't drawn to scale because you could just move one side and technically you could change the scale. Therefore, that technically wasn't drawn to scale. But then the other one where the triangle was drawn inside of the waterfall, you have to fight me to decide that it isn't drawn to scale. Some people will say it's not drawn to scale because they ignore the background, and some people say it is drawn to scale because they don't ignore the background. But for me, the diagram is part of the background is part of the diagram. It makes it make sense to me. So yeah, hit the subscribe button if you appreciate what I've done so far. And you can get a point by just giving the answer, but let's see what they say here. Triangle JOE has vertices whose coordinates are 4, 6, 2, -4, and 6, 0. Prove that JOE is isosceles. So the first thing, the use of the set of axes on the next page, which is actually these axes, I've moved them over here, is optional. So I'm going to actually graph this. 4, 6, -2, 4. Now I'm graphing this pretty quickly, but I am comfortable with graphing pretty quickly. So you should count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, etc. And then 6, 0. And according to them, this is an isosceles triangle. Let's see. There we go. Okay. And this was J. This was O. This is E. So this is an isosceles triangle according to them. And I mean, I clearly the bottom side, the OE, is not the side that's congruent to any other side. So clearly, I'm going to try to prove that this side and this side are congruent. Let's do it. So I'm going to call this. So J is 4, 6. So this is, I'm going to call this X 1, Y 1. O is negative 2, 4. I'm going to call this X2, Y2. And E is 6, 0 is X3, Y3. Okay, so let's see. I have to get the length, I have to do the distance formula, right? So the distance between J and O, the JO is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I plug in some numbers here. Turns out I don't have to simplify in the end. Well, not all of it in the end, but radical. So x2 is negative 2 minus x1 is 4, close squared, plus parentheses y2, 4 minus 6, close squared. A lot of students get this wrong because they insist on not using parentheses. Like the teacher says use parentheses, and students are like, nah. And then the moment teachers are like, don't use parentheses, they're like, I'm going to put them all over the place. You can put parentheses, and if you don't put parentheses, it's wrong. Therefore, you have to use parentheses. Okay? So simplify this. You could actually simplify it on the calculator at this point legally. So you got negative 6 squared plus negative 2 squared, which is equal to radical 36 plus 4, which is equal to radical 40. I did that for edification purposes, but you could skip right to this by doing the inside in the calculator. Okay? And that is legal for full credit. That's a point already. Let me see, it might be 3 points. Yeah, that's, I think, 1 point, maybe two. That may 1 point or maybe two. I would have to look at the grading, but it's either 1 point or two. But notice, if you happen to remember the distance formula, you get points because now you realize that you have to get OE. You have to get JE. JE is equal to the square root. Now I have to use the correct numbers, so it's x3 minus x1 because E is x3 y3 squared plus y3 minus y1 squared. Okay, cool. Let's do that. Equals radical x3 minus x1 is 0 minus 6 squared plus y3 minus y1 is 6 minus 4 squared. And we've actually this simplifies to all the other old arithmetic. Negative 6 squared plus 2 squared, which actually we did very similar here. That's radical 40. And there's part one. Since JO equals JE, triangle JOE is isosceles. Nice. Now I'm going to take a screenshot of this because I actually need this diagram in the bottom part. Prove. So we're going to make another diagram here. I'm just going to remind you and thank you for sticking around for this video. I know that these long form videos are really popular on YouTube. One of my videos got like over 30,000 views, which is what motivated me to do these. Excuse me. And what's motivating me to not do all the editing is that now I can actually just make videos, make 7 videos per season. And that is my goal, 7 videos per season. Let's see if I can actually do it. Now, what does this say? Point Y, 2, 2. 2, 2 is right there. This is point Y. Is on OE. Prove that JY is the perpendicular bisector of OE. Okay, I have to prove that it's the perpendicular bisector. So let's prove that. first I'm going to prove perpendicular. So the slope, remember that perpendicular lines have slopes that are opposite reciprocals of each other. So I have to prove that the slopes are opposite reciprocals of each other. So the slope of OE is equal to, let's see, y3, change in y. Remember, it's delta y over delta x, right? Which is equal to y3 minus y2 over x3 minus x2, which is equal to, so I have to prove that, yeah, these are perpendicular, right? That's the goal. So 0 minus 4 over 6 minus parentheses negative 2, which is equal to negative 4 over 8, which is equal to negative 1/2. And you could remember, you could simplify that on the calculator. Negative 4 over 8, math, arrow frac, convert to fraction, negative 1/2. And now I have to prove that the slope of jy is the opposite reciprocal of that, which is negative of negative, which is positive. 1/2 reciprocal is 2, so positive 2. The slope of jy is equal to, again, delta y over delta x. So I'm going to call this point x4, y4. So this is equal to x4, no, y, it's delta y over delta x. So y4 minus y1 over x4 minus x1. So that's equal to 2 minus 6 over 2 minus 4, which is equal to negative 4 over negative 2. And negative 4 over negative 2. Let's not get this wrong here. Negative 4 over negative 2. Math, convert to a fraction. It's just plain 2. So MOE is the opposite reciprocal of M slub JY. So so OE is perpendicular to JY. And that is 5 out of 6 points. 5 out of 6 points. Now, you might say 5 out of 6 points. Now I got to prove that it's the bisector also. And that's one more point. How could that be? Because to prove that it's the bisector, I got to do literally the distance formula for OY and the distance formula for YE again. Actually, you don't. It turns out the this makes JY the altitude of triangle MOE of JOE from vertex J in an isosceles triangle. The altitude from the vertex angle. The vertex angle meaning the I know that all the vertices of a triangle are vertices, but when we talk about an isosceles triangle, we talk about the vertex to be the one vertex that's made by the two isosceles, the two congruent sides. So from the vertex to the base. So so in an isosceles triangle, the altitude from the vertex to the base is a perpendicular bisector. Is the perpendicular bisector. the perpendicular bisector of the base. I know that some students say correctly that all the sides are bases, but when we're talking about an isosceles triangle, again, the side that's not congruent to the other two sides, if such a side exists, that side that's not congruent to the two congruent sides is called the base. So is the perpendicular bisect of the base. Therefore, JY is the perpendicular bisector of OE, and we have gotten 100 on this Regents. So I want to thank you so much for sticking with me through this whole video. I really look. I know you can do it. All you got to do is do the work that you got to do to learn how to get the answers, and show the work. But not only that, on the problems that you don't know how to do, you have to use your correct math to eliminate answers. That's the process of elimination method that makes this video the GOAT of all math videos, because nobody does that. What they end up doing, they just do a bunch of problems and hope that by some osmosis that it just kind of sticks, and that just doesn't work. So if you appreciated this video, click the like, click the subscribe, comment, let me know that this is the GOAT of all videos, and I will see you in the very next video.